Welcome, everybody. Tonight is the 27th of July in the year 2020 that just never goes away, so we'll call it 2021. But anyhow, we are here again on Dill's Personal Robotics Group Robot Builders Night Virtual. We're just going to do the usual thing and go around the table and talk about our various robot projects and any questions and lessons learned and the like. Tonight, I think we're going to start off with Ray. So, Ray, sounds like you have some interesting updates on Imu Calibration. Is that the case?
Yeah.
Please do. Take it away.
Okay.
And for those that might not be aware, IMU is inertial measurement unit, and we use it to measure like orientation and direction and compass heading and things like that.
Can you see my screen?
Yeah.
Okay. So this is, I'm going to try to make this bigger. Oop. Guess that's as big as it gets. Okay. So this is, you're looking at an image from an OpenMV H7. And the camera is staring at a compass. And this compass has zero drift because the Earth's magnetic field isn't changing. And if I have I have a neodymium magnet that I can bring closer to it, so it starts to affect it about a foot out. And I opened the compass and got rid of the oil, so it does bounce back and forth, but a normal oil-filled one won't do that. And these down here are the degrees that it's reading. So it should kind of settle, maybe 96, 97, maybe. But when I, bring the magnet closer to it, like about a foot away, and it starts to deflect, and I can steer it around to different angles, and it's doing about, well, with the IDE on and connected, it's doing about maybe 18, 19 frames per second. So basically it's just using blob detection and finding the where the centroid is, and then what the angle is of that based on where the centroid appears on the screen, and it reports in like 0 to 180 degrees. I think one of the things that I can do, since it's 0 to 180 in both directions, and not like 0 through 360, I can just look where the centroid is, and if it's like above the center of the compass here, I can just say that's like a positive angle, and if it's below it, it's a negative angle. Right now, it just gives me positive angles, 0 through 180. But it's pretty good as far as drift. It doesn't really drift because it's not using MEMS sensors to try to do it. It's just a magnet basically, and I'm using OpenCV techniques to find out where it is. So I think if I enclosed it and had a constant light source, the colors wouldn't change. And or this could be used to correct like a B&O 055 or 85. So what are your
Ray,
thoughts?
what happens if you put metallic objects nearby? I mean, a magnet is one thing, but a metallic object could, of the right material, could modify the flux lines.
Yeah, they could. I can get a chunk of metal here somewhere.
But that if I get what your drift is, that's pretty cool, because what it means is that you could then patent that and tell Bosch to just go away. They just need to mount an open MV cam and one of those compasses and in a
Yeah.
module, and then we could package that in our watches and phones. And oh, never mind. I'm sorry.
Those are some really cool graphs. What are you using to draw those graphs?
That's just part of the OpenMV IDE, and that's the color space is LAB. You can change it to RGB, YUV. There's a couple selections there. Right now it's just on LAB. And you can either, I guess I'm not showing you this. You can either have a serial terminal or not, and you can decide what to print. Right now here it's just printing angle, and this is just the integer value. You can make it a floating point number if you want.
All right, so that's a function of the OpenMV IDE.
Yes.
Yeah.
And I just put a link in the chat to the main site.
I was going to bring a chunk of metal up near it, see if I can get it to move around.
But you're not sharing anymore.
Yeah, I know. I'm about to.
Okay.
I suspect you'll have problems if you try accelerating or moving the compass around.
I don't know. The oil-filled compasses are pretty good. They tend to dampen most of that out. Okay, this is
just playing with compasses though, like in a car, because they have the mechanical pieces, they don't tend to do very well when they're moving or especially accelerating. They'll bounce around.
Oh, will they? Yeah. Yeah, it varies a little bit, but it's like a 1-inch lead screw. It weighs a ton, and I'm kind of bringing it up to the side of it, so it shifts it a few degrees. But I was, if I would use this, I would stick it mounted on a plastic tube, so that those effects are minimal, away from pieces of metal and that kind of stuff. So I don't know if you're kind of looking for a relative value anyway. So I don't know if that would take care of itself or not. It may shift it a little, but it's probably always going to shift it the same amount. So if you know what your starting angle is, say whatever your orientation is. But yeah, it does move. If I bring it up like right next to it, like here I'm about a foot away, and yeah, I can get it to move a degree or two. Just by bringing it up like an inch or two away from the compass, but I wouldn't be doing that normally.
So the hard iron would have the similar effect to this approach then as to the Bosch sensor.
It probably would, yeah.
Isn't this pretty much the same thing as a compass though in a Bosch sensor? It's just a lot larger scale.
Well, I would argue that the fusion algorithm that Ray has is pretty different from the fusion algorithm in a Bosch BNO 055.
That's for sure. I don't know. I don't know what the MEMS sensor is for a compass. I thought they were, I don't know, microscopic pieces of metal that reacted to different things, either acceleration or. Oh, Doug's shaking his head. What?
They vibrate. Doug's muted.
You're off, Doug. Oop.
Yeah, they're silicon. They're silicon based, and they're like Carl said, they're kind of like they're like tuning forks, and
yeah,
their oscillations potentially change the resistance on a Wheatstone bridge type thing. But I was thinking about what you're doing here. I'm sure everybody here has kind of thought about that at one time or another.
Yep.
But
Probably
the
me
thing,
more than others.
but one of the things that would I could see some application to this. I want to say if you go back through the tapes of previous meetings, David only uses the magnetometer when he starts off, because the GPS, once you're rolling, it knows what direction you're going in. Okay.
Mhm.
So it's just, how do I get so that my robot doesn't have to do like a complete circle at the starting line? You know what I'm saying? So he
Right.
likes to have a starting value so that he can correct once he starts moving, that he's kind of in the right direction. So, if this thing's just sitting there at the starting line, it'd be nice if your camera could like be dual purpose.
Yeah.
Maybe you're looking for the cone most of the time, but when you're not looking at the cone, you drop down and look at your and you get your initial starting thing. And
Yep.
and you could also, here's another thing you could use it for, is so you got your IMU and everything, you think everything is cool, and this would be a real sanity check, like if your IMU is saying you're going north and your compass is saying you're going east,
Right.
right off you got an issue before you start. So I mean, there's definitely I could see some use for this strategy, but
Yep.
but if you have your BNO 055 properly calibrated and everything, I think it would be just as good. Because like I said, I don't know if you're going to use it continuously through the whole thing. At least I wouldn't. I'd switch over to the GPS as soon as.
Doug,
Yeah.
I was under the impression that David, after he got going, was only using odometry and the accelerometer and gyroscope, that he wasn't using a GPS at all, was he?
Yeah. Well, you got to watch because David's robot has evolved over years. If you look at the very early videos, he doesn't have a GPS on it.
Like does like the hat, he does that hat trick video where he drops his hat and it comes back. I don't think that had a GPS, right?
That was
no, he didn't need it for that.
that was odometry and
Yeah.
gyro.
So you don't need that when you're going waypoint to waypoint. In theory, you don't need it. Because if you can interpret the longitude and the latitude into a distance and a direction, then you can waypoint it all the way. All right, but it's easier if you don't have to worry about the robot between the start and when it starts picking up the cone. So he's monitoring for that cone is all the time, but he doesn't expect to pick it up until he gets a certain distance from it. And if he gets to the GPS, to the GPS coordinate, and there's no cone, then he goes into a search pattern. But he uses and I will say this: he doesn't use an extremely up to date GPS. He has a Garmin E-Track or something that he puts on there and just on a serial port and pulls it off of that.
Yeah. I was going to say MaxPi makes a camera mux, and that's basically, it's just a multiplexer. It's not a binocular camera setup. So you can bounce back and forth between the two of those. And they have several different lenses that you can put on this. Some of them are, they have like I don't know, maybe a 3 or 4 inch extension on it. So, you're not tied to close proximity to this board. You can actually bend the flex around to where you want. So I could use one for looking for a cone and the other looking at a compass or something.
Yeah, but I think it, I guess there's nothing wrong with that approach, right? I'm just saying is if I were going to do it that way, I'd probably look down at the compass and then pivot up. Because
Oh, yeah, but there's
especially if you're going to have it correcting for,
declination.
yeah, if you're going to be
Yeah.
doing that anyway, then it's not a big deal. You know,
Anyway, I just had thought about this for a long time. Just as
like
kind
I
of a
said,
crazy
I
idea.
think
And
a
then,
lot of people have thought about it, but nobody is that I know is actually taking it to the point where you actually set it up and looked at
to
it.
the
One last
crazy
thought.
point.
One last thought was that Ray, you might want to the centroid. You
Yeah.
might want to like impose a circle. You know what I'm trying to say on
Yeah.
your and so that and find out where that centroid tracks in the circle. And if it is, you know, then you could use the circle to give you maybe a little better visual. It wouldn't make the number any better, but it would make visually.
Yeah.
You might,
Yeah. Yeah. So it was just, just a few lines of code, really just blob detection. And,
Mhm.
it was pretty simple to do. And I think I would enclose it because, how the lighting affects, blob detection,
Yeah.
the light gets a little
Mhm.
more intense and now the
Yeah.
color's out. And, but with controlled lighting, with an LED and a diffuser, I think I can, make it so it's impervious to outside lighting conditions, especially because you get the sun and you can get some really intense light on the thing. And
Well, here's another idea. Just since we're talking crazy here, you know the LED rings that
yeah,
that were that the 16-bit one, the 16 LED ring would give you, 16 points, the major points of the compass.
I'll have
And
to try the world's smallest ring light, for
well, no, what I'm trying to say is, but if you could have your needle go over those LEDs, do you follow what I'm saying? You could have
oh yeah,
a similar thing, and in fact, it could probably be an LED ring. You can't have one that where you change the colors. It would have to be just straight out LEDs. Because
right.
an LED can be used as a sensor too.
Yep.
You just shine light at it,
Yeah.
and so you could have them together and then just follow their shadow.
Hey, as long as we're coming up with crazy ideas, I have one.
Go for it.
Take your compass and mount it on a tall pole to the north of wherever you're driving around and use your camera to look for that compass. That way you know that direction's north.
Yeah, but how do you, well, wait a minute.
And you tie a witch to the pole and
Yeah.
ask her which way is north.
That's right.
That would help too.
Yeah.
So Ray, are you going to replace your standard IMU with this? Shall we call it the Pirates of the Caribbean compass?
Yeah,
approach?
yeah. I don't know. I wanted to try it outside and see how it did, and because I know there's kind of weird iron deposits, out where I live, and it may be useless outside. I don't know. But just walking around in here, and that's like 4 feet off the floor. It doesn't seem to be the compass doesn't seem to be affected by, rebar or anything. But and like I said, with a pretty powerful neodymium magnet, you'll have to get like within a foot of it to start to move the compass needle. So
it would be worth looking at with your IMU, see if you put it under the same conditions, how would it deflect? I mean, just
oh yeah, right, because it would
90 degrees.
same changes in the magnetic field.
And then the other thing, one of the problems with that, and I can't remember who mentioned it, I think it was Ted, that outdoors it'd be bouncing around a lot.
Yeah.
Well, so now damping gets real important, and
Yeah.
the more damping you do, the less responsive it is. So your robot can turn a lot faster than a really fully dampened compass could. So now you start talking, well, what do I dampen with? What type of oils and blah 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 blah.
Oh.
Yeah, you could take this a lot. You could get this You could take this a long way. Or you could put it on a gimbal.
On
Wait
a
a minute.
gimbal. Ooh,
You
yeah.
know, sort of like an
Yeah.
IMU.
Yeah. Yep.
I'm just kidding.
Anyway, I thought it was kind of curious to,
Yeah.
it does not drift. So, you can
Well, but
move
it's
there
not
and
very
spin it
accurate
around.
either. It's not very accurate either. I mean, the best you could hope for was a couple of degrees, I think.
Speak for yourself. It's the accuracy is yet to be proven.
Yeah, well,
Ray's thrown down the mitten, so
yeah, I'm saying go for it.
I'm going to be really impressed if I see a robot that has this style of compass navigation on top. That would be worth some kind of an award. I'm not sure which kind, but it would be worth an award.
Yep. The Crazy Town Award, maybe.
Especially if it was calibrated against one of Ted's compass on a post ideas.
Yo,
Yeah,
Rube
yeah.
Goldberg, we already got a term, Rube Goldberg Award, you know.
I'm going to make a suggestion. I think we have a young person here who we should have go now.
That's right. Yeah.
You want to get
You-
Franklin to go next?
Yeah, all of us will talk for hours and hours, as we've amply demonstrated. And I think we have a
Okay.
young person here who's eager to talk, and I think we should let him.
Well, Franklin, are you ready to go?
No,
Or do you need a little more time there, buddy?
because I'm making the new line following code and I am not done yet.
Okay. Well, if you're okay, we'll come back to you. Franklin's a very patient guy, and I want you guys to be just aware that he'll give a good presentation as soon as he's done with it. So, Chris.
Yeah, since we were talking IMU, so quick update from my side with the BNO 85. And my thing on top here spinning around at up to 1200 RPM. So one question that was there from Dave: could it be just the presence of the motor, rather than the vibration? So one test I did is I can actually control the RPM through PWM, right? So I can crank it up from, almost nothing to the full 1200 RPM. And it's pretty clear that once I go beyond, let's say 900 RPM, 1000 RPM, that the vibration affects the IMU. I don't know if there's subtle impacts below that because I haven't done long-term tests, but once you go beyond a certain RPM, you can literally watch the angle that comes back from the IMU, change in real time in like 0.1 degree more, 0.2 degrees more. I mean, it really changes fast. Again, at the lower RPM, I haven't spent enough time to confirm that there's zero impact, but definitely no obvious impact. Now, the other thing I noticed in terms of vibration, I'm not sure how to show this necessarily, but there's a lot of slack. There's a lot of slack in these motors, okay?
Yep.
So I can rotate the platform by 2.5 degrees, without even moving the motors. It's just the slack in the gearbox, okay?
Yep.
Those are not the metal gear motors from Polar Louis in there. They put some plastic crap in there. But so the reason I mentioned that, because one thing I noticed is, I think the fact that the platform is not sort of rigidly kind of situated on the surface, with the vibration coming from the LiDAR, it's kind of the slack in the wheels, right, is kind of allowing my platform
To
to
vibrate.
shake a little bit more than it would if there was no slack. It's just a hypothesis that the fact that my platform it's light to begin with, right? But the fact that it's allowed to sort of jiggle around, is probably not helping, with this vibration-induced coupling into the IMU. So I don't know. I need to play around with a few things. I noticed maybe just adding a little bit of weight in the right place, not on the spinning LiDAR, but just on the platform. I might be able to get to a point where I can just bring it down enough, right? So I'm kind of below the magic threshold, and I think there is some magic threshold. So that's my plan. But I really need to try it in action. Again, just sitting on the desk is not really a good test. So I really need to see, okay, what if I'm actually moving around, and compare with and without LiDAR spinning to what my IMU is giving me. I haven't tried any kind of filtering ideas yet. Didn't really have a ton of time. Haven't tried any of the balancing of the LiDAR yet, which was suggested somewhere online, which would involve a lot of trial and error. But I suppose that could fix it. It's just, you need to do a lot of trial and error, and to do that systematically, if I really wanted to go that route, right? It's almost like I would have to put a little mounting surface on top of here on which I can then mess around, without destroying this thing and reposition something. It's almost like a whole other sub-project on how to efficiently balance that thing. So I'm not going to go down that rabbit hole, but it's just something interesting that probably would work. So I think what I'm going to do is put a little bit more weight to my platform, and well, maybe I'll have to accept slightly lower RPM. Again, I was hoping to really crank it up to the full 1200 RPM, which amounts to a 20 hertz update rate on the LiDAR, which is really why I got this one. Now, okay, it's only spec'd for 15. I mean, 20 hertz, frankly, I'm already pushing it beyond what they kind of advertise for this. This is it's the slightly more expensive one, but still they only advertise 15 hertz. But you can easily get 20 hertz update rate, if I can. But maybe I'll have to stick to, 18 hertz update rate or something like that, just below the point where my small platform starts shaking too much. So,
Hey, Chris,
Did you try mounting it on rubber or something to isolate it?
I haven't tried that really. Again, haven't done any. I've done one very, very brief and superficial test with some foam that I had floating around on my desk, and that didn't do any good. But it's so I'd have to put more time into that. I really haven't given it a good try.
What's your accelerometer saying?
I'm not reading that, so I'm using the BNO85 in the mode where it only spits out rotation vectors, and I'd have to dig through the documentation again to see what fusion, if any, it's doing in that mode. It's optimized for very quick update rates, like optimized for VR headset, the kind of movement things where you want, instantaneous update. So it may be doing less sensor fusion. And I haven't asked for the accelerometer data. I guess I could ask for that. It would just come in addition.
I'm just saying, if you varied your speed of your motor and you watch the accelerometer data, you get a feeling for your vibration.
Yeah, I need to see.
And you should see a frequency, a frequency that probably related to your actual rotation speed.
Well, okay. That's kind of what I was going to suggest is, I don't know how I'd use the information, but I think it would be interesting if you had an audio bandwidth accelerometer, or even just a microphone might work. And if you could speed that into an audio spectrometer, and then if you could look at the power spectral density as you increase the speed on the motor, you might be able to find some like mechanical resonances inside the LiDAR or in your structure or something. I mean, that's basically how we did it back when I was in the military stuff. And we were measuring the mechanical resonances of the tank structure and how those would translate from the treads through the structure to the mounting point of the periscope. Anyhow, it'd be a fun exercise.
Would be a fun exercise.
Talk you into doing it.
I had a lower tech solution than the Army tank, but it was basically to cut a disc of fuzzy Velcro, put it on top of that, and then you could take a loop hook side piece with a little bit of metal or whatever and move it around until you get balance. Some kind of, that way you could play with the balance.
Yeah. I mean, you're right. I mean, again, that would be a fun exercise trying to balance. One idea I had, if I were to go the balancing route, right? Because there's two parameters you need to vary. There is the position. Well, actually, there's two axes to the position, right? How far off the center you are, and then where on the disc you are, right? And
Yeah.
then there's the weight
Yes.
of the balance weight. So I was wondering if there's a way to combine all that into a little thing that can be easily tweaked like a knob almost, where I was picturing a stick kind of thing mounted on top, okay, in such a way that I can slide it, okay, because then that sliding, right, it kind of shifts the weight, right? It shifts the weight. And then I want to also be able to rotate it around its center, right? So I can kind of, divide it into 12 or 20 different sort of angles and then shift it around this way. But either that or some sort of grid, right? You'd have to systematically say, okay, now I'm going to try it at this location, this location, this location, and so on. It'd have to be pretty systematic so you can see.
Carl, is that double-sided tape?
You could do a design of experiments on that,
There you
Chris.
go.
And then all you could do is use
Back
this
to
special,
school. Back to school.
this special engineering fastener material.
Hey, Chris, a lot of those things, they start off and do their initial calculation of balance using a small p of modeling clay. Just something to think about.
It's so practical.
Just stick it on there. Now, obviously at 1200 RPM, I'm not sure if it could hold on there, but I know that that's what is a way that a lot of people start to do initial balancing.
But that's where you need a measure of better and worse, right? So you need a definition of done, and the one definition of done is that the IMU messes up, but the increment leading up to that might be if you had a audio frequency spectrometer.
And then I guess another one is I don't know if it's symmetrical all the way around because it's got those ports, but it would be interesting to see, just the run out of the motor and see if that has anything to do with it.
What do you mean by that? Can you clarify?
Yeah, you take a dial indicator and just go along the top and rotate it and see.
Oh, see if it's the shaft is bent or not perfectly concentric.
Yeah. Assuming that the spinning piece is symmetrical, whatever it is. I mean, I know it has the two ports for the in and the out.
Yeah.
But there might be an area near the base of the spinning part. The spinning part's going to kind of be like this, and with the port in the middle there.
Yeah, I mean,
but
just looking at it from this angle, because the bottom piece, it's just like 2 millimeters wider than the top spinning piece. Okay, so if I look at it like from this angle, okay, I mean, you guys probably won't see this, and then start to move this, I can see how the top disc, right, is not perfectly centered on the bottom disc, right, by a millimeter or a millimeter and a half.
What about your other unit? Is your other unit better?
Yeah, that was
But the top piece is also asymmetrical, right? Because it has an opening, it has an aperture for the sensor. Yeah. So the asymmetries are going to lead to weight imbalances too.
Yeah, but for run out, you wouldn't worry. All you need is something that's supposedly the same distance away from the shaft all the way around. Okay? Because you're not really measuring balance, you're measuring shaft run out. So, I mean, if the guy's wobbling like this, he's never going to be in balance.
Yeah, I mean, basically there is a very, very, very slight wobble that when you crank it up to 1200 RPM, it starts to, to really make a difference.
Hey, Chris.
Well, but you don't know if it's a wobble or if it might be something like bearing noise, right? I mean, you don't know which effect is causing the microphonics problem.
Well, one quick way you can find where it's wobbling towards is just get very close to it with a marker while it's spinning, but you just barely touch it, right? And that'll leave a mark on the side that it's wobbling, if it's wobbling at a precise frequency.
Then, like I say, then you could look at your accelerometer data, and if it's wobble, you should really see.
Yeah, I should look at that accelerometer data. You're right. I mean, that should be revealing. If there's a certain RPM where it really picks up, I should look at that.
Chris, have you ever looked at the PWM signal that drives the motor? Does that look like it has kind of like, bunching where the duty cycle is?
No, I haven't looked at it. It's being generated by the Pi, but it's hardware PWM. So at least that's what I'm using. So I'm pretty sure it's a clean signal, and I think that would be low on my list for investigating.
Okay. Well, maybe if there was, I don't know, extra resistance with the belt, or maybe the belt sits in one part or one position and gets kind of in that mode for a while or something, or if you could even see any periodic variations in the PWM, like, was indicating that there was additional resistance or something, maybe.
I think the first thing I'm going to try, which is probably the easiest, right? So if I just add some weight to my base, because again, just adding a little bit of weight seems to make a noticeable difference just from looking at, the bass shaking and the sound. So I'm going to try that first because that's the easiest, because maybe I just need a heavier bass.
Well, cool. You're making progress anyhow.
Yeah, very little. Got some home improvement to take care of. That's been keeping me busy. So
we understand that. Okay, quick check. Franklin, you making any progress?
According to me, I finished, but it doesn't work.
Okay, why don't we give you a little bit more time? Is that cool? We'll come back to you in a little bit, okay?
Well, I don't know what to do next, and it doesn't work.
Oh. Well, would you like to just show what you have and see what people might have to say about it?
Yeah.
Okay, so everybody, this is Franklin. He's a cousin of mine and very interested in a lot of things. Franklin is entering which grade again this fall?
I'm going to go into 5th grade.
The 5th grade. So, but Franklin is a sharp guy. So, Franklin, can you just explain your project and what it is you're trying to do and what you've done before and what you're doing now?
Yeah, okay. So, right now, we're working with the MPOT, and I made this code with it that tells it to do things like this one tells it to do a little dance, and this one tells it to do all the notes, and then this one should tell it to, whenever the line detector turns on one side, the light is supposed to turn on, but that one doesn't work. And then this one is supposed to make it follow the line, but it doesn't work.
Does it do anything at all? Any lights turn on, or does it look like it's got power? Or
when I do this one, when I upload it and turn it on, it just spins in circles and doesn't let me do anything with it. But it's not supposed to do anything until I press one of the buttons. So like if I press 0, it's supposed to follow the line, but once I turn it on, it just starts spinning in circles. And then when I press C, before I did this, it didn't do anything.
Well, what's the first thing that it's supposed to do in that list?
Well,
What's at the
here,
top? Play notes.
Oh, well, the first thing on the list, when I press A, it's supposed to move forward, backward, blah, 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 blah.
So you're saying all it does is continuously rotate? when you press the button, or does it even wait for a button press?
Well, before I made this one, and this one worked. So when I pressed A, it would do what it says here, and then it stopped. And when I pressed B, it would do this. And these two still work. But after I made this and I put it on this line, when it's finished uploading, it just immediately starts spinning in circles and doesn't let me do anything.
So that little section of code that you're pointing to right now is what you changed, right?
Yeah, because originally I only had from here to the top to stopping right here. But now once I added this, it just starts spinning in circles and doesn't let me do anything.
Okay, I'm not an expert in this MBOT, but looks like the loop is missing. Once you press the button, it gets in, it maybe does something, and then there's nothing to continuously.
The loop is around the whole thing.
Yeah,
At the very top, forever loop.
forever.
So you need to keep pressing the button. Is that how it gets into the if statement all the time? Because once it gets into the if statement, there's nothing to keep it following the line. It might just get in the if statement and then come out of it. That's what it looks like to me. There's no loop inside the if statement.
I think you're right that right after the loop, there's a that if statement. That's what you're talking about, right?
Well, it's supposed to keep doing this over and over and over again.
But as long as you have the 0 button pressed, then it should go into that, right? And then do if the line follower sensor port 2 is white on the left, go forward and turn left. And then if the port 2 right is white, move forward. Well, still move forward and turn left. So there you go. You're always turning left, whether the left side is white or the right side is white. So maybe you want, are you trying to turn towards the line or away from, you're using one line sensor, not two?
Well, when the left side, when the left side is white, it's supposed to move forward and turn left. And the right side is white. When you put it on the circle that's going left, it should also turn left.
Ah. So it's only ever going to turn left.
Yeah, because it only needs to turn left. Because when I do it on the circle thing that you printed out, if I make it going left, it doesn't need to turn right ever.
Okay. And then, yeah, and then at the very last thing there, you have it turn left at 50% for 30 seconds. So
that's if
If no buttons are pressed.
That's if they're black. If they're, because when they're not white, it just does this, and after 30 seconds, it just stops. That's if it's not. That's if it's black.
well, if the 0 is pressed, then it'll do the turns. Otherwise, it'll just turn left for 30 seconds.
Yeah, I think that outer if statement, if you just get rid of that completely, that would be better.
I get rid of this, and then I get rid of this. Now it's just if lines follow a center portion left side being white, move forward, then left. So right when I turn it on, it just starts going left.
So you're uploading it now. Can you put your camera on and show us what it's doing?
Yeah.
So by the way, guys, he's using Scratch, obviously, and this is using a transpiler. So it's converted it to Arduino. That's GCC you see in the background, and it's uploading it so it'll run just like any Arduino code in the robot. I think, Franklin, you need to stop sharing so we can more easily see your camera.
Oh yeah. Okay. Here's the.
But basically, this little MBOT platform is really pretty capable and pretty cool. I wound up getting 3 of them, one for me, one for Franklin, and one for another nephew. And I printed out these. Oh, no, I'm talking. I might need to pin Franklin's photo, but I printed out these little sumo rings so that the 3 of us at a family gathering could do little family sumo. It took them 1.5 hours to assemble and then start to go through the tutorials on Scratch. But it's really a pretty capable little system. And these guys were moving along really quickly, and for entering the 5th grade, they were doing pretty good on their own.
I vote we give Franklin an award of being able to use Google Meetup better than anybody else on this channel.
Okay, but when I press the 0 when it's supposed to follow the line, it just makes like a humming noise while I'm pressing the button.
Yeah. Well, it sounds like we need to spend some quality debug time on your software there, Franklin.
Just going left and alternating like real fast.
While I'm pressing the button, it just makes this sound.
That's the sound that robots make before they destroy the planet. I remember that from a 1950s movie. It's totally be careful.
So is that the button that's meant to make sound? Because it could be that there's certain buttons that are already mapped. So you need to look at what is mapped at.
I just found something. When I make it when I take it off the ground so that the sensor becomes black to when I press the button, it doesn't make that sound. It only makes that sound when the left one is blue. So now it's not, and now I can't hold anything for once.
Without sound. Okay.
When the left one blue, when the light is off, dang it. When the light is off, it doesn't make the noise. So maybe it makes that noise because it's trying to do something, but it can't do it.
Franklin, can you describe that sensor? Is that 2 separate sensors, or is it one? Are you following an edge, or are you trying to follow the line?
I'll show it on their yard better. Looks like 2 sensors.
Well, this is Franklin. Yeah.
And so apparently the camera senses some purple light that my eyes can't see.
Infrared light.
That's the infrared, Franklin.
Yeah, my eyes can't see that, so.
Right.
Yep.
But he was asking if there's 2 sensors there, and it looks like there is, one for the left and one for the right.
Yeah.
Most smartphones will show you infrared LEDs that you can't see with your eye.
Yeah, so when the left one when it senses something, it's supposed to go forward and left.
Right.
And then,
so when you put it down, is there a light on top of that sensor that changes color when you slide over a little bit this way or that way?
well, so right
slide now over to the left. Okay. So you notice that the light changes.
Yeah, because when it detects when it detects white, it detects something and it turns on. But when it's black, it doesn't really see anything.
Right. So in your code, what you need is on the left sensor when it's off, you need to turn the robot to the right side. When the sensor is blue, then it means that you will need to move the robot to correspondence. In other words, right now where you have the robot, okay, slowly slide it over with your hand to the right side. See? So that means you need to have your the robot turn over to the right to get to the right line. Okay?
Oh, so
So in your code, what you want to do is start off maybe, let's say, on the inner side of the black, and then turn the left motor on.
It doesn't matter that much. You can choose to follow either the
Right.
outside or the inside edge. This is edge following, and and with I assume it's a waggle type edge follower,
Well,
right?
it
could be.
It's basically a waggle approach, right? Because you get an on or off. You don't get a gradual
right.
Well,
value.
it depends on how big the line is regard to the sensors. So we really don't know that for a fact.
Well,
That's
no,
why
that
was
the interface did not give you. It just gave you true or false, if I recall seeing that interface.
Right. It's not an analog. It's
so
just
it doesn't
an on
have a
or
left
off
and a right.
for left and right. So it's by definition, it's got to be some kind of waggle because there's only two of them and it's only binary. But
So you don't have a sensor for the individual light. In other words, you don't have a sensor for the left and the sensor for the
no, he
right.
does. They're individual for the left and the right, but it's not an analog signal, right? It's just on or it's off.
Right, it's on or off. And what I'm telling you is that they could both be on if they're in the center of the line.
Right.
That's true.
Okay. And it's all determined by the width of the line.
Yeah, I know, but if you just do a line, if you do an edge follow, right? That's I think that's the algorithm that he's looking at.
And
right
to
now.
be an edge follower, by definition, you need to be on the one left side or on the right side. You can't be in the center. That's what I'm saying. Start from one side or the other, but not the center. Then, if you're doing that.
Really?
Franklin, can you show your code again?
Yes, we need to see the code again, because
what it's supposed to do is it's kind of supposed to do it one at a time.
I think there's no condition for when the black sensor is, when the left sensor is on the black, it's supposed to just go straight. I think there's no condition for that in the code.
When it does when I had it with the right side underneath, it's supposed to do it one at a time, which is not how this works.
So let's start at the very top of the code. You need to step through the code because that's what the computer will do. So the very first thing is you should have a while loop. That basically is a continuous forever loop, right?
Forever, right.
Okay, because I can barely see the line, so that's why. Okay, and then after that, you have what? Something that says for whatever, something there.
It's like think of it like a switch or a case because he's got he's got different modules in a way for different buttons.
So that's just a label. Then after that, the while. What's the next line? Or can you enlarge this a little bit?
And that's the if statement to check if what button on the remote was pressed.
But if it did line follow,
right, but what we need to debug the program, you need to concentrate not necessarily at the end, but at the very beginning, and sort of step through it.
John, the stuff up top is just lights and sounds. It's got nothing to do with the actual.
Okay.
So the section at the bottom that he was at is.
Yeah, but when he puts it down, he pushes a button, right?
Yeah.
So is that button defined?
Yeah.
And where is that defined?
That's the bottom section right there with the pressing O.
Okay.
So when the line follow, if it did line follower sensor, blah, 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 and then if it detected being white, then it needs to move forward and then turn left because it's a circle. And when you move forward, the circle, since it's going left, the circle would turn left. And then if it did the thing after it, let's just say this was the thing after this and it was going right side. If the right side was white, it also needs to turn left because it's still a circle. So if you have it going left, it would still need to turn left. So if it did it one at a time, it probably worked better, but it does it all at the same time. So it just keeps turning left.
So you probably need to think through that a little bit more, right? So you're assuming it needs to turn left because you as a human can look at the whole pattern and you know that it's eventually going to turn left, right?
Yes.
But if you think about it from the point of view of that robot, that it can't see the whole thing. All it can see is what it sees down below it. It needs to think. It needs to know whether or not sometimes it'll end up going more straight or a little bit more right in order to get back to that edge, right? Because it may not see that edge in the sensor that you're looking at. So even though the larger pattern is turning left, probably here you need to have a little bit of a right turn if you're not seeing the right light underneath the robot, just to get close to that edge that you're tracking again. Does that make sense?
Yeah, so maybe after this, I could do like this, and then let's go there. This goes here, and then if the right side, if the left side is, you could just do a turn right and then do this over and over again, but go forward.
It still says white. You meant to say black, right?
Yeah. So if it goes, so once it detects the left side being white, goes forward, then left. And then after that, if it detects the left side being black, it needs to go forward and right, and then just do that over and over. Have this in between, like this one, and this one, and this one 2 times, and this one, and then do that over and over again.
Let's give it a try.
So when you turn right, when you tell it to turn right at 50%, does that mean it's an in-place turn, or does that mean it's more of a gentle curve than turning right at 100%?
When it says turn right at 50 power, that means how fast it turns right.
So
Franklin,
okay,
does it like
we can just try this out.
Sorry. Go ahead.
When move forward at power 50%, it can go slow, faster, or as fast as it can go.
Right, that's the speed of the reel, basically.
This is this.
Well, I think that the move forward is going to be immediately replaced with the turn right or turn left. So you're never actually going to see the move forward necessarily. But that's okay. We can test it and see.
Right, we can see.
And that probably could be the reason for humming motor sound, because the IR, when you press a button, it's pulsing maybe at 50 hertz. And then for 50 times a second, it's just going in, trying to move the motor forward, trying to move the motor left. And then it immediately goes out of the loop, then comes back in after 50 milliseconds or 40 milliseconds. And it does that quickly again. Probably that's causing the hum. So if you put some time delay there for it to go forward, maybe for 10 milliseconds, 50 milliseconds, 100 milliseconds, and then turn left for 100 milliseconds, and then repeat the loop, it could work. Or we need to put a forever loop inside when IR remote 0 is pressed. If you have a loop there, then it's going to work fine, I guess.
Yeah, that's a good point. Yeah, you may want to have a delay. Or, well, yeah.
Or like a wait, wait 0.5 seconds. Like wait 0.5 seconds.
No, very short delay.
Like 0.1 seconds.
0.05. If you just make it something different from what it is now, then you can see what it does and then learn and then dial it in. But because there's a delay in there somewhere, right?
You don't technically need a delay if you remove the forwards, probably. I mean, it's just going to keep doing, yeah, but it's okay.
Well, that's true too.
Let's see what it does.
Where's I'm trying to find wait.
Well, there you had, like it had the things there for move forward for X seconds, right?
Yeah, you really don't want to do that.
Yeah, it has move forward for how many ever seconds you want.
But Kareem, instead of delay, you could just say do that for point. I mean, it's going to be blocking code,
Yeah,
right?
that's Well, yeah,
That's a four loop. That will work.
that's that's the problem. It will be blocking code, and
Well,
and
you
you'll skip over.
well, you cram it in there between the two.
So if I do put that and then put this here, and then I do this,
Like 0.1 or something, right?
0. Wait,
Point,
no,
can you do 0.1?
0.1. And then I can duplicate this. And it's not gonna work. Wait.
So the thing is, Franklin had this working before, and this IDE that they provide is actually pretty good, and you can actually save things. You can do modular. If you click on that orange thing to the right, it'll actually show you the transpiled Arduino C code that results from this. So as a learning tool, it's pretty remarkable, really. But Franklin had this working before, and I think why don't we give this a shot, and then maybe Franklin, you and I can go work on it offline and get it working again, and then you can give a demo when it's working again, because you had it working at one point.
Yeah.
Yeah.
So the secret is when it works, keep the code, and when it doesn't work, fall back to the code that works, and then add. You'll learn that that's a very good technique. People do that all the time.
So I add in all of these so that it does something, because it needs to do something. And then after all of these are in, then I need to do change left,
Okay.
left, white.
Okay.
Left.
And at this stage, I would suggest you compile and run, because the key is when you want to build a program, you build it in blocks and small blocks, and you add. In other words, at this stage, you're adding way too much now, so we won't really see. There could be multiple places that could break now.
Left side, and I need to do left, right, I think. I can't tell. Left, right, left. I'm just gonna try this and then upload.
Yeah, at one point, Franklin sent a video of this thing turning until it found an obstacle, and then it went forward to push the obstacle. So he's
Pretty cool.
and actually, this is the compile and download firmware mode. It has a live mode, which is a lot slower, but it actually, I think, it executes the code on the laptop, and it does basically.
So you're still turning left every time.
Stepwise.
Oh no, I thought I changed those to right. Oh, I changed these. Okay, well, that's what I changed. Wait, when I made that one where it waits till it finds an object, that was not on this. It was on the mobile.
Yeah. But you still made it work, right? That was the cool thing. You got it to work.
Yeah, and then this one has to go. And then this one has to go back.
Left, right, left, right.
Left, right, left, right, left, right, left, right, white, black, white, black.
Yeah.
Okay.
So I'm going to suggest also that you could simplify this and just use one of those sensors, and it would work probably
Easier.
more reliably, or certainly easier to debug.
Yeah. This is a lot to think through right there, but.
Because these may be conflicting with each other a little bit.
Moment of truth. Demo effect time. If you could unshare and show your screen, Franklin.
Yeah, this is if the 0 button's pressed.
Okay.
If the 0 button's pressed, I didn't switch camera.
You just demonstrate.
So I have to unplug the robotic And I'm just gonna put it right. And then it starts. So now it's not just turning left, and if I press 0,
Oh, you got
That's
motion.
it moved.
It
Okay.
moved, but it didn't
When
turn
I
left
press
very much.
That's because we didn't put the time for the
That's
left
right.
and the right turns.
Yep.
This is definitely progress, but I think if you just add the
Uh,
time to those left and right turns, we should be able to get it to follow.
Yeah, that definitely doesn't work.
But you made progress, Franklin.
Yep.
Yeah, at least it goes somewhere. Just
So
goes
Franklin,
straight
why
in.
don't you start on the black and try it one more time, and then we'll show you what we do on this club when people get things to move.
Okay, hold on, I need it.
Okay, you're putting on the black and you're trying it again. All right.
Okay, so both sensors are on the black.
Okay.
Hey.
Oh.
You're almost there.
Well, so now they're both. My phone keeps telling me.
I would try it with just the left sensor and see what happens.
I think that is a good suggestion.
Okay, so if I put just the left sensor onto the white.
No, you'll have to change your code still.
In the code, what he's telling you is that there's a conflict because there's too many sensors. And it basically says, oh, this sensor is
So
on.
while I'm holding down the button, it just goes straight.
Right.
So there, you got two suggestions, Franklin, and I'm going to suggest you do this offline, and I'll help you with it if you want, and we can come back. But in the code, you want to do the thing that Raj said, where you add some time after you tell it to turn left, make it turn left for a little while, like a 0.1 seconds. And then the other thing that Kareem suggested is to just use the left sensor. Instead of trying to be Mr. Fancy, use the left sensor and the right sensor. Keep it simple and just use the left sensor. But for now, what I wanted to show you is that on what we do whenever somebody gets something to move is we give them a big round of applause because it doesn't always happen. So way to go, Franklin. Way to go.
Yay.
That's good. Good.
Yay.
Progress real time.
Yay. Yay. Yay.
And you've accepted
we done clapping. We done clapping.
So, okay, so Franklin, thanks a ton. So let's you and I connect offline. And then, but we got a lot of people, so we're going to move on, okay? Good, that's a thumbs up. I love it. Okay, guys. So I think, Murray, you were somewhere in the next in queue there somewhere.
Okay, yeah. Congratulations, Franklin. That was great. We look forward to seeing the thing driving around in circles. Cool. I have finished the hardware and the electrical installation on my letterbox robot, and I will blog about it, but I'm at the point now where the code that's running on it is just very simple code that just hits the various inputs. But I got my first mail, and I could see it in the video. I could tell that there was mail out there. That's all working. What I'm going to do now is actually take my Python robot operating system and actually implement that on the letterbox robot, which was the original intention. And that way the PIR sensor and the door sensor are inputs, and the output would be the LED strip light and the things like that. So I'm going to actually use the robot operating system. And with that in mind, I'm going to try to share my screen. I've actually gone to the trouble of diagramming what this thing looks like. And I always forget how you share screens. Present now? That's right.
Yeah.
A window. Oh, where is it? Oh, God. Not that thing again. Here it is. Why does it not show up? I can't. It doesn't actually show up as a window, unfortunately. Oh, there it is. Oh, that's weird. Come on. No. There. I think I got it. Yeah, I'm having trouble getting it to select the actual. I keep getting the other window. Come on. There. Oh, well. Maybe I should just share my screen because I can't actually select the window. As soon as I go to select it, it flips back to this one. So I'll try that again. I don't know what it is about this, but it's just tricky. There we go. Okay, share. And then I'll flip over to, now tell me when you can see the diagram.
Bingo. It's loading.
Okay, that is the robot operating system. The pink bar in the middle is is an asynchronous message bus. This is all implemented in Python, and all of this is actually in place right now. Down the lower right-hand corner is the Thunderbolt motor controller. I've got a motor class for each one of those with a PID controller and a jerk limiter in the PID controller. I mean, in the motor class, and then there's a motors class which kind of provides slew limiting and kind of a velocity, well, just a velocity controller. And then the motor controller, that's the lower left, basically takes dispatch events on what the motor controller should do from the controller, from the arbitrator, going back up, and then that message comes over the message bus. The purple stuff are all the different subscribers to messages, which can receive either bumper or infrared inputs. There's a behavior manager, which manages what I have been calling higher level behaviors, which we kind of had called ballistic behaviors. But basically what they do is that they send a series of events in order to run through, let's say, a roam behavior. Then up on the top is all the inputs. The pink stuff is the gamepad publisher, which I don't actually have running right now. I used to. There's an event publisher, which will come off of the infrared and bumper. And then the potentiometer is just a digital potentiometer I'm using currently for doing testing. It just controls, it sends basically the output of the potentiometer as a motor velocity and runs all 4 motors just as a test. And then the orange stuff is basically the OS itself, the Python OS. So that's kind of what I've got running right now. And then for the letterbox, I'll strip out most of this and just add in the few pieces. There won't be obviously a motor controller. It'll just have the inputs and outputs for the actual letterbox robot. So in any case, that is, I can stop sharing. And let's see.
How do you test your jerk limiter?
I can't get back to the screen. Here we go. Okay. The jerk limiter, I don't know whether it's really a jerk limiter. I had a conversation. We've got on the personal robotics group, we got this guy who's he's an engineer in the Army Corps of Engineers. So he's really an engineer. And he was the one I was discussing, and it's not really a jerk limiter, but what it does is it keeps the motor controller from changing too rapidly. Let's say from going full on forward to full backwards, or just stops it from making radical shifts so that it won't damage the motors. That's all it's really doing. And all I'm doing there is just every time it gets pinged, it keeps track of the last ping. And if it's too big, it just limits it to a fixed limit. So it's not that complicated. It's just kind of a safety mechanism.
But how do you test it?
I'm not sure.
How do you know it's doing anything useful?
Oh, well, it's very clearly doing something useful because a lot of my code right now isn't working properly. And so, for example, I've got a keyboard input for various things. And if I say go half forward or full forward, all the motors will be going full forward. And if something breaks, all of a sudden it tries to go to either stop or to full reverse. And this will actually interject and only let it gradually on that 20 hertz loop make those changes. It's very simple. It's nothing complicated.
How do you know it's jerk and not acceleration?
If it goes way too fast. If it tries to go from, let's say, it's a 0 to 1. So if it goes from +9 to positive 0.9 to negative 0.9, that is by definition too far. I've just got a fixed setting on what the threshold is.
Karim, I think Murray, are you just using the word jerk in a casual sense? Or are you referring to actual kind of the derivative of acceleration?
Well, in the
That's
sense
what I'm
that
asking, yes.
you get into an elevator and the elevator moves too fast, and that's considered a jerk. It's that kind of jerk. Not in the formal sense, in the mathematical physics sense. It's a let's keep this thing from changing too radically. That's all.
Okay, I understand.
Yeah. And like I said, I had this discussion with a guy, and he's from Mississippi, actually. And I couldn't think of a better term for this. It's basically a safety feature on the motor controller to keep it from changing too quickly.
Okay.
And jerk seemed like the closest, even though I know that, as he told me, physicists would have a conniption fit.
Yes.
So jerk isn't the derivative of acceleration? I thought that
Yes, it is.
It is.
But this is
I'm
not
not
that.
really doing a jerk limiter. Not really.
Okay. All right.
it is effectively doing that. It keeps it from jerking. You can't go from like full on forward to full on reverse in one go. So it kind of effectively is that, but it's not in any real sense. It's just a safety feature.
Maybe a slew squared limiter. I don't know.
I couldn't think of a better term, and I like jerk limiter. It just sounds good. We need more of that.
Maybe a yank limiter.
Well, it's sort of like guys that send giant rockets that look like body parts into space. That would be a jerk limiter. We need a jerk.
Well, I'm glad you didn't call it a Herald limiter. So, you know, that kind of thing. I'm just saying.
I was going to go with a Herald.
Yeah, Bezos limiter.
A Bezos limiter, yeah. There's been articles in the New York Times about that whole thing. In any case, that's what I'm working on. I've obviously you can see that the project is considerably complex. The fact that it runs at all kind of surprises me, but it does run. And let's see, is that it? So I have my Pi 4 with a little screen, and that's the controller now. So I'm trying to have it because I've been doing it. I've been SSHing in from my desktop, but I don't always have my desktop handy. So if I go out on the front deck, I can carry this with me and control the robot remotely. I was using a laptop, but it seems better to use a Pi to control a Pi. And I think that's it in terms of, like, I haven't had any shipments of parts, and the projects are like the letterbox robot. I'll blog about. Oh, it turns out that a 2.5 meter strip of LEDs, when lit at night, lights up the whole front of my house. It's quite frightening. It would scare the hell out of anybody if that came on while they're turning around the corner and all of a sudden it goes. So I've got to like put kind of a shield on it or something to light the path and not the whole front of the house. It was remarkably bright.
Yeah.
So I've only got a digital relay to turn that on and off, so I can't PWM it or anything. In any case, that's it from New Zealand.
Cool. That's a lot of progress for a week. Good deal.
Yeah.
I think we had next in line John.
Yeah. I took a little side trip here in my motor control project. One of the problems I've been having occasionally is about 4% of the time when my Raspberry Pi reads via I2C from a motor controller board, about 4 to 5% of the time, the most significant bit is set instead of clear. So I'm getting errors, and I had a hard time figuring out where the heck this was coming from. I searched high and low on the internet to see if anybody had similar problems, and apparently my problem seemed to be fairly unique, but I do have a sort of a workaround solution now. So just to hopefully I won't bore too many people with bit banging display here. But whoops, let's see. Share first. Present. Screen. Share. Okay, there we go. So this is my little bit-scope mod logic analyzer. I'm showing here the white line on the bottom is serial clock, and the brown line is serial data, and I'll describe what the red line is here in a bit. But I annotated this so that you can easily see what's going on here. I'm just doing a single byte read from the Raspberry Pi, reading from the controller board. So you get a start bit, 7-bit address, the write bit, and the act to say that, okay, the slave has seen the address and now is ready for more. And so the master Pi puts the register offset on the bus. The slave controller board reads it, acknowledges it, and does another sequence here where there's another start bit, puts the address back on the bus again, and then the master indicates a read is going to happen here. The slave acknowledges and puts the data on the bus. The data finishes, it gets napped, and you get a stop bit. So the problem here is right around this area here, where you can see that.
Can you zoom in a little bit? I can't see anything. This is like way zoomed out for some reason for me.
Ooh, I don't know. Let's see if
like most of your screen is just the background, and a small portion of your screen is that window, and then that contains the tiny screenshot. At least for me, it looks like that. So
Here we go. There's the zoom. How's that?
So we're
No.
looking at your Discord.
What? Oh, you're looking at Discord? Oh, no
Yeah.
wonder. We're on the wrong screen.
That might make a difference.
Yeah, that would make a big difference.
Or maybe you just assume we all have like super sharp eyes.
Let me
You
try
know?
that again. I was
Oh, I
sharing-
forgot. I got reading glasses. Maybe I need to put those on.
I'm thinking an award should go to Chris for actually speaking up while the rest of us were just jawing
Yeah,
the
it's
floor.
Joel.
trying to-
Finally,
What the heck is he talking about?
yeah.
Okay.
There we go. Oh yeah.
Oh, that's
Let's
different.
go.
Right. So this is basically the read sequence for an I2C interface. So you can see I've annotated all these 7 bits for the address, the register offset, then the 7-bit address again, and then a read signal, an ACK, and the data. Well, the problem here, right around this area here, where you see the data stays high, basically this is a transition between when the slave has got control of the master's got control of the data bus, switching over to the slave having control of the bus, and the data stays high for a period of time. So this right here is actually correct read, because you can see the clock goes high after the slave drops the data bit to low. So it actually comes out as correct as a 5. Now, in the case where it fails, let's see, is this a failed case? No, hang on. Here's the failed case. In the case where it fails, for some reason, we get this little glitch right here where the clock isn't pulled back high again until kind of late. And for some reason or other, this bit gets read as a 1, and that comes out as a 1 here. I guess I should have annotated that as a 1 instead of as a 0. So one of the interesting things that I found is this only specifically happens when you see this red line here transitioning. What this red line is here is I have another interrupt for the timer that supports the PWM. And this problem only occurs when when the interrupt fires for that timer driving PWM right at the end of the act. And it's kind of strange because the PIC only really has one ISR. And what you do is when at least one interrupt happens, you go down the list and checking the interrupt flags. It doesn't matter if another interrupt happens while you're processing the first one. It's still got to finish processing the interrupt service routine, or basically you check the flag, you do the processing, you clear the flag, you move on to the next interrupt. So theoretically, the software processing this timer interrupt should have absolutely no effect on delaying this signal here, or on changing the timing of the signal. What I found, oddly enough, is the solution to this problem is when you look at this is my I2C slave handler. In between the time when I write my data byte into the I2C buffer, after you write that to the buffer, it falls out of this if statement. I'm going to ignore this because this is my solution. But before I put this loop in here, what it would do is it would fall to the end, and this is where the slave releases the clock. And that's the signal to the master, the Raspberry Pi, says, okay, the data's out there, you can read it now. Oddly enough, if I put a delay between when data is written into the PIC's I2C buffer, if I put just a short loop here, a do nothing loop, that delays the time between when I write to the buffer and when I say the clock, release the clock and let the master read, that pushes out, let's see if I can show the corrected one now. That pushes the clock out here now to where the rising edge of the clock is clearly past this little area here where the data is still high. But the interesting thing I found is that when I did this, I go from like 4 to 5% errors to absolutely zero. I mean, 10,000 reads and not a single error. And that's at 100 kilohertz on my I2C clock rate. So that definitely fixed it, but it's not software that seems to be causing this. It seems to be something in hardware. Something about when another interrupt fires, there's something that causes the hardware to delay getting the data from the buffer, or at least delaying the clock. I'm not sure what's going on there. All I know is that this is a workaround solution.
My team has to fix it in software all the time.
Well, there's no reason why that delay should have, there's no reason why why this ISR should be having any effect on the result, because it doesn't change what the software is doing at that moment. Because you can only process one ISR at a time. But
maybe it has something to do with the guts. I mean, if you look a few layers below the block diagram in there of what the hardware is doing, maybe that helps account for it.
Yeah, I don't know. I might even post something to Microchip and ask them about that, because that's really kind of weird. Anyway, that's all I had.
That's cool. It's nice to see a detailed thing like that. Okay, maybe I'll jump in now. That's all right. So I'm going to keep talking to hold the display. And so then I'm going to ask a question. So in terms of the outdoor competition in August, I got a little delayed, but now I've got a helper. So let me show what I've done, and then mention Raj, if I could pass it off to you then. So basically, this is the, if you remember from a couple times ago, whoops, there we go. This is the platform David Anderson gave me with, which was his son's 30-year-old outdoor racer thing. Its wheels are not anywhere near big enough to do the grass. But last you saw this, it didn't have an upper deck. And now, after this last weekend, it actually has, I just copied over the hover sim kind of stuff. So it has an IMU in front, and then a ring light for direction and status lights in the back. And I figured out also that I'll turn on the speed controller here. And it actually registered that time. So now we can actually see that it's gotten, woohoo, 4-wheel drive. It's got motors moving. So this is going to be true to its name, duct tape and baling wire. And the next step is to go and now that I got the basic controls and stuff working, the next step is to go and finish connecting the heading loop, so that I have the heading loop working for a Mecanum wheel, but not for Ackerman. So I got to do some spaghetti code adaptations to make the heading loop work so it can drive straight. And then, so since it's not going to work on the grass, all I'll be able to do, hopefully with help from Raj, is make it go find a cone and come back on the street or driveway. But if I can do that, I'm going to feel good about it. And then that leads me to Raj, who we spoke with last week. And it turns out that Raj was looking for someone to partner with. And I feel really proud and honored that Raj chose to help me on this crazy duct tape and baling wire thing. So Raj is going to add some professional computer vision to that thing for cone detection. So if the contest was on concrete, you guys better watch out, because we'll clean your lunch.
So those wheels won't go through any grass at all, or?
Well, it's the whole speed versus torque thing. And at least when I tried it in my grass before my surgery, it would get into the grass and then just stay there and spin its wheels. So, I mean, it's 30 years old. The suspension is kind of shot, and it's got this spindly little thing that connects the motor from the back to the front. I mean, it's just, and now it's got a paper clip because one of the drive pins snapped. When I had it on my high-tech official test stand, right?
Yeah.
And I was spinning the wheels, and at that point, the drive shaft broke because I tried to spin it, and that's when I have to replace the drive shaft with a paper clip. So I'm going to be lucky if it makes it. We're going to be lucky if it makes it to the end of the driveway and back without falling apart. But we'll see. Driveway first, maybe grass then. Or if we can get Steve to trim his grass like a putting green, then it might have a chance.
Might work. Huh? Yep.
Yeah.
Carl, I just hope this isn't an allegory for all of our own physical bodies.
Well, you're talking to the wrong person right now for me on that. So.
Well, my birthday's tomorrow, and I'm getting old, so it just feels like, here we go.
Every time that clock ticks over, another one.
Yep. Bad.
Aren't we all getting old?
Yeah.
Yep.
Hey, so let me ask one question, and then I don't know, Raj, if you wanted to talk about how far you've gotten, but
yeah.
My question is, so how many people on the call, if we start remotely, so how many, I see Pat and Ted, are you guys both interested now in doing the August competition? Are you still on track?
Yes.
I am. Go ahead.
Go ahead, Pat.
I am definitely interested. I've been programming like mad, and I'm at the point now where I've got, I managed to borrow a couple traffic cones. And by the end of the week, I plan to be doing a first test to drive out using GPS coordinates. In my back, there's a little back park behind the house, and I'm going to try to go to the first cone and see if I can get there and back.
Cool.
So my biggest problem, I'm looking for an IMU. So we had discussed earlier, knowing your compass direction before you start. So which way is your robot oriented? And it's pretty much the only thing right now I think I'm going to use an IMU for is just to try to get a compass heading. But they're all pretty much gone. Everywhere you try to go with the chip shortage, unless I spend $50, for an IMU, it's not going to happen, I don't think.
Or Ray's solution with a real compass and a camera.
Yeah.
Just have my camera look down once in a while at the compass.
Yeah.
Hey, Pat, would you be interested in a BNO 055? I have a couple extra. I could just mail you one.
That would be greatly appreciated if you want to do that.
Okay, yeah, I'll have to get your mailing address here.
Okay.
There is another option too at Amazon. I just purchased a BN 800. It has a built-in compass on top of the GPS. So
a BN 800.
Yes, it's a very affordable device. I think I paid under $20 for it. It's only $2 or $3 more than a regular GPS.
See if anything comes up.
End-off. Nice.
Do you have a link for that?
Yeah, I can look it up in my Amazon orders.
Yeah, I'm not seeing it. It's not coming up in Amazon for me.
Hey, Pat, I also have an IMU that I haven't used in a while. It's a pretty old one. I'm not sure if that I do or not. So if you want, I can lend that to you.
That was at 880 and all.
I know that this probably because of shipping and the dollar to pound conversion might put you over the limit, but I know that Pimoroni actually is very different than Adafruit, but Pimoroni right now has at least, looks like at least 4 or 5 or 6 of them in stock. And they're going to be around 13 pounds plus shipping, 15 pounds. 14
Okay, just a minute.
Yeah, that seems to be one of the problems I'm having is shipping to Canada. I'm at $50+ for
Hey, I'm used to that.
Yeah, well, I would rather try to put it into something else.
Sure.
But
I was just pointing out that they are in stock in the UK. It's about the only place I've found that still has stock.
Yeah, that's the problem I'm having as well, is stock everywhere, and what is available seems to be right now very expensive.
But another hack could be if you have an Android phone lying around, you can just put that on the robot and use a software to do a UART or Bluetooth into your controller.
From what is using? What was that? Sorry, I missed it.
There are some softwares that I'd used in the past. It can connect to UART over Bluetooth. I don't remember the exact software, but there are some apps that you can just install on an Android phone, and it'll share all the sensor information, including GPS, all the IMU, gyro, accelerometer, all of that information, compass, the heading of the compass, everything. It streams out on a Bluetooth UART channel.
Okay, I have a compass heading off the GPS as soon as the robot starts moving. It's that when it's standing still, the initial position, I don't know. So the only way I can think of doing it right now is just make sure the robot's always pointing north at the start.
Well, or I think, Pat, something that we talked about doing, at least locally, is that I think the first cone, per the rules, should more or less always be in sight, if I've understood it.
Yep.
So if you can, from the starting line, if you can see the first cone, and if your robot can drive straight, you just aim your robot at the first cone, off you are to the races.
Yep, and that is true. But then again, with a 3.5 or a 3.6 millimeter lens on a camera, it's an awful long distance. Let's say at 300 feet.
Without a zoom, that would be pretty hard to do.
Yeah. So I'm counting on using odometry to get me into the range. Once I'm in the range, is to start using a camera.
Well, but that's one. But okay, but I mean, just eyeball on this physical shape of the robot, aiming the robot towards the cone, and then odometry, and then the camera for the last bit.
Yep, that's the plan. Once I'm within range, I know my compass heading, I know where I'm going, I know my odometry. Basically saying, okay, I should be in the area. Let's turn on the camera and start looking for a cone. So,
all right. So my current plan is to head down to Dallas and meet you guys there.
Oh, wow.
I figure it'll be less embarrassing if mine's a complete failure, because I'll be with at least one other person who will have trouble. So.
You and I, buddy. So, okay. And Raj, to the extent that he wants to be associated with it.
Yeah. So, yeah, I heard there is some people having trouble driving through grass. So I won't.
Somewhere. Yeah, you don't have that issue, do you?
No. So I've actually made some progress. I've been able to send it out a few hundred feet and kind of go for some coordinates and drive back. And I've got that working. I haven't got the sensors working at all, so it doesn't see the cones yet.
Okay, but that's still okay. So this is cool. Okay, so we got Pat in Ontario, Canada. We've got Ted coming to Dallas. So just a quick head count. How many others in Dallas might have something? Harold, good. Doug, Kelly. So that's that's at least 4 or 5. Kareem, did I see a hand raised there? 5. John, maybe 6. So we'll have 6 or 8. Okay, this is good, because I need to talk to our venue host, Mr. Steve, and reconfirm that we're still on. Ask if he can mow his lawn like a putting green, and at some point, I don't know how we'll do this, but we'll send a survey out or something, but we'll need to get a more precise head count so we can start to plan like food and such.
You should have the robot mow the lawn for you.
I just
right,
wanted to,
as it goes
Yeah,
up,
right.
mow the lawn.
Bonus points.
He's got quite a steep lawn there. That's and actually some of the grass he put in turf because he was having erosion issues, and so that could be putting green like, very fine. So
And I think Ray does mowing robots, so yeah, we could cover this.
Are we going to allow spectators?
We'll let Ray go first and make a path.
Yeah, right.
You may not want to follow that path.
Big divot.
Is the challenge cone going to be on the other side of that ravine?
Well, I don't know.
Or
Where
the lake,
no, I haven't even looked at his property yet. But I will say this: the rule set, just for clarity, doesn't guarantee that the first cone is in sight. 95% of the time it is, but it doesn't guarantee it. It does guarantee that there's no obstacles in the way to the cone.
Except the horizon.
You know, whatever. Yeah, you know what I mean? So just for, that's just a little clarity, but you know.
But the human alignment trick, so that the human initialization should still,
probably
more or less.
Yeah.
Will the safety officers be wearing orange as well? Because
No,
mine's a lawnmower and everything. They might chase them.
We actually have a classic video when we did this down at the Dallas Nature Museum, where we had a member. He had his robot and he was using vision, and we didn't go 100 yards at that time. We only probably went 100 feet. So he was going along perfect, right at the cone. And another member, who was a photo bug, stepped out from behind a tree, and he had fluorescent orange shoes, and the thing went just like that. And that it was just, and we caught it on tape. It's just really classic. Poor Eric had a lot of problems. He also has the classic circle of death, where he hit rebarb and his compass went into a circle, and he just. So if you go look in the archives, there's a lot of cool Robo Columbus fiascos. We also had.
How does the non-guided version of the rules work for the second and third run?
Oh boy.
Okay.
This sounds like a can of worms.
Otherwise, no, I think you'd go for it the other way, Kareem. If you want to go for the non-guide, you're talking about the 3 waypoint challenge.
Yeah.
Okay. You'd run your first 2 runs using without walking the course. Just let your robot do its thing.
So somebody else has to hold the kill switch?
Somebody else is supposed to hold your kill switch. If you read the rules, somebody is supposed to hold your I think one of the judges or someone's supposed to hold your kill switch. Okay. Now, if you're walking there, you can tell them, hey, be quite honest, we're pretty slack on this. If you're walking it, you could hold your own kill switch. But if you read the rules, somebody else is supposed to hold the kill switch for you.
Okay.
Yeah, and let's see. But like I say, if you're going for the challenge, you probably want to run your first 2 with the challenge, and then say, "Oh, dang, I didn't." By that time you're either dancing in the streets, or you're a little bit worried about maybe you'll lose it. In that case, you might want to just go walk the course and readjust. So in theory, if you're on the course, you probably want to follow your robot. You're probably going to have a camera and you're going to video it, but you're not supposed to take new waypoints. Do you know what I'm saying?
Mm-hmm.
So, I'm not saying you couldn't change your waypoints. I'm just saying you're not supposed to. You're only supposed to have 3 waypoints, the cones. All right, and how you get to those waypoints is through your obstacle avoidance and all of the cool things that you can do. But you're essentially given 3 waypoints, and they're where the cones are, and that's it. You don't walk the course, you don't do anything, you just go to them. Now, if we found out, oh God, one of the waypoints was wrong, you could fix that. But you know what I'm saying. It's really, David asked for that this year, and what he was looking for was how do you get people from waypoint driving to waypoint and obstacle avoidance. That's what he was trying to do. Most of us aren't ready for that. Now you guys might be. Scott's definitely could do that, and David can do it too. So, I mean, it's really a case of how do you get to those 3 waypoints we gave you.
Okay.
Yeah, I'd love to give off those cups. That'd be cool. Anyway.
All right. Hey guys, I think I lost the order somehow. Took a detour, but so Raj and I are we're going to have a team entry here on the asphalt version of the at least first 2 cones. But so Raj, do you have a little update to share on the OpenMV cam?
Yeah, let me share. Yeah, here's the OpenMV cam. Again, thanks, Carl, for this, learning this, and quickly jump start on it. And it's pretty simple. If anyone's looking for computer vision, one of the easiest things that I came across so far. So pretty good. Where is the IDE? Okay, I'm going to share my entire screen and then we'll go from there. Okay, share. Let me know if you're seeing my screen.
Mm-hmm.
All right. So do you see my IDE now?
Yes.
Okay. So here's some code that I took off of the example code and started tweaking it. Okay. So this is the code that I have. It's looking at the cone, and I kind of tuned it to look at this color. And when in the color space and started tweaking these thresholds to like identify specifically the cone color. Again, if the white balance is continuously changing, it could be off. So I'll have to tune this threshold on the computation day or just generally outside. I haven't tuned this outside, but right now it's working in this lighting condition that I have. And it's detecting the cone. It's basically detecting that color and blob. And I have some conditions to prevent it from picking up something else and calling it the cone. So what you see here on the right top corner is a video coming from the camera. And then I'm getting the centroid for it and kind of printing out the X position and the Y position for the cone that we're detecting. And you can see this is in computer vision, this is the left top corner is a 0, 0. You would see that it gets close to 0 and 0. I think I didn't initialize it correctly. I'm going to run this again. Okay. So you'll see that the terminal that's printing on the left side, the first number that you see is the x-axis. You can see that it's coming close to 0 because the cone is on the left side. And then as it goes to the right, the centroid, it's tracking the centroid, and then the centroid number on the X goes really high, close to 300. I think the shape is 320 by 240. So that's the number that you're seeing, the first number. This kind of tells us whether the robot should turn left or right. And then we have the other number, which is the y-axis. This should be close to 240. And then this should be, how it's going. You see that the number on the right, second number, is decreasing because it's on the top. Plan to use these 2 numbers to kind of say where the cone is and should it move forward or stop or something like that. We haven't figured that out yet, but this is the progress made so far, just to confuse it and see if it picks up other colors similar to red or the orange cone that we have. You can see this is of the similar color, but it doesn't pick up. This is because it's specifically tuned for. So I don't see the other confusing version that battery there. That is not confusing it. I don't have the USB.
Your resolution's kind of high and your frame rate's kind of low. Can you deal with probably if you knocked it down to QQVGA, your frame rate would probably double.
Yeah, right now I didn't focus on that, but this FPS that you're seeing is the FPS on the IDE, but the FPS on the on the camera itself is very fast. So once we don't show this and it's running independently, the FPS is, last I was, right now I'm not printing it, let me print that as well. So we see what the FPS is.
Oh, it's in the bottom right-hand corner there.
That's the FPS on the IDE, but the FPS on the camera is 22 right now, 22, 23.
Okay, yeah, definitely. You disconnect it from the IDE, it can double or triple.
Yeah. So yeah, so I'm happy with 20 hertz. 20 hertz is great. Even probably 10, 15 hertz is still good, I think. And don't expect any cause of blurriness to motion blur or anything to confuse the robot. All we are looking at is the color blob. I was thinking about identifying the shape, but I haven't gone that far, thinking that someone might be wearing a safety vest that's an orange color, and that might confuse the robot.
Could screw it up, yeah.
Stop presenting.
Don't give people any ideas how to confuse your robot.
We've seen that before in indoor competitions, actually. So not to name any names, but there have been people that were relying on certain colored markers, and then all of a sudden, the competition day, magically those same colors just showed up in the wrong place at some point, and no blood.
Really?
But it
What a coincidence! Who knew? What a coincidence!
Who knew? Yeah, if only it was a secret that we were using orange cones. Yeah.
And orange flags. Yeah. Yep.
But I don't think we don't discuss countermeasures in the rules. So this I think is where the peer pressure and gentlemanly common sense comes into play, I suppose.
There's no mention of you can't use something called flaming death rod at bad colored things. There's no rule like that, is there?
And check
Well,
your
at the
orange
time, I
color
wasn't breaking any rules.
Check your
But
orange
after that,
color
there's a
shoes
new
before.
rule that said you can't do that. So.
No names. No names.
No names.
No names. Okay. Hey, well, thank you, Raj. That's really cool. And I'll text you. Thursday's looking good if we start at a certain time or later. So for me.
Sounds good.
And welcome to the Makerspace. So congratulations to signing up. We now have another DMS member in the club. That's very helpful. That actually means that for anyone who does have a DMS membership, you also get a Gmail account with that membership. And with that Gmail account, you can jump straight into, if you log in to this meeting with your Gmail account for the Dallas Makerspace, you don't need to ask for permission. You can just join straight away. So that's a benefit of joining DMS and being a member of a DPRG as well.
Are you saying that there's a separate email ID that we get with at dallasmakerspace.org or something? Okay.
Yep. That's how it's actually through that account that I have through my Makerspace membership. That's how we've had these meetings hosted now for the last year and a half.
I had no idea. I've been a member since inception. And I had no idea that I have an email address from
I didn't either. But so you're thinking of being there Thursday then?
I think at the moment probably Raj and I will be there Thursday evening.
Yep.
Okay, I might show up if you have a rough time.
We haven't figured out that yet, but
okay.
I was thinking 7:30. Does that work, Raj?
Yeah, if possible, maybe a little earlier.
I could do about a 7, but I have a 6 o'clock call. It turns out my daughter for her wedding.
Sure, yeah, that works for me.
Cool. But yeah, Kareem, if you want to look into it, so the Makerspace, I mean, there's a bunch of online resource that you can use through that, but the email is just one of them.
Cool.
Gets you another 30 gigabytes of Google Drive too, so whatever. Okay, so let's see. Anyone else? Who else has something?
I
to
have
talk
something
about?
I can show you relatively fast, sort of offline, but let me.
Okay, by order of hands, let's go John, Kay, then Pat, then Harold, I think.
So, in the process of, let's see where we, yes, there we are. So in the process of surfing the web, I ran across that. So, you know, the limits are on. Seemingly there was a robot that played on the court. So,
Yeah, I saw some clips of that. That robot's pretty cool.
well, it looks pretty scary there. I'm like, wow. And what it does is, let's see if this will work. The resolution is not as good here. I don't know if y'all can see it better, but it seems it can shoot pretty good.
But that, and yeah, it's going to back up now on its rollerblade.
Yes, I was going to say it looks like rollerblades or something.
Oh God, is he going to make the shot from mid-court?
It just sinks them.
One-handed, no less.
Wow.
And nothing but that, man.
And I bet its armpits don't smell like a. Okay, never mind.
Grease, yes.
Remember our multiple watchers.
He's not covered in sweat, huh?
That was always my issue playing basketball.
I think this is on a loop. We've already.
I don't know. That's why I'm trying to decide if it is or isn't.
It's only just 52 seconds, so this is the second time through.
Yeah.
Okay.
It only shot 3 balls, I think. But it is pretty remarkably smooth. If you haven't seen the video, it's worth searching out and looking at.
So yeah, I thought that was interesting. As I said, though, it doesn't look very nice. Wide, less light. So maybe there's a camera up there on top. It's hard to tell.
Death ray.
Maybe. So I thought that was cute. So I saw that. So
Who needs expensive basketball players when you got that? Make a team out of that thing.
They're probably at a comparable price, right? So.
Yeah.
I was thinking probably more expensive than the actual players.
Could be.
They didn't show it handling somebody trying to interfere with them either.
That's where the death ray comes in.
Cool. All right. Well, thank you, John. Let's see. And then, Pat, were you next? Who was next? Yep. Okay.
I have just a quick little presentation. If I can share my screen.
Ooh.
I'll share the entire window. So I don't know if everybody can see that.
Mm-hmm.
So that's the Raspberry Pi running OpenCV. I'm detecting a traffic cone, in this case, a little 6.5 inch tall cone sitting on a chair. And in the bottom window, bottom left, I'm getting back from it, basically the size of the pixels coming back in the right-hand window. So the size detected, which is 52 pixels wide by 71 or whatever the case may be, it's bouncing around a little bit. And that's on the right side here. And then I draw a circle around the center of that. And then I get the position, XY position in the left-hand picture. So 209 by 370 roughly. And I calculate a distance. In this case, my distance is wrong because I got a 6.5 inch tall cone instead of the proper height cone at this point. But basically it was working not bad for distance. It's close. And then I get an angle, 13.41 degrees off of center, and that's approximate because it depends how far away or close I am. But and out of that, I get a linear velocity and an angular velocity. And that's what's in the bottom right window. I've got a MQTT message going out with linear, angular, a flag, and I forget what the last one is. Priority or something, I forget what it was. Message going out. So I'm publishing it on the screen once a second, but I'm actually sending it quicker than that. So that's what I've been doing. Basically in preparation for this contest.
That's looking pretty cool.
Yeah.
So I had a lot of trouble. I started with an RGB color or RBG or GBR. I forget how they labeled the other one.
Yeah,
and I switched to an HSV, but it still gave me a lot of trouble finding a color to match for the traffic cone. And I'm picking up some reds with it or I'm picking up some browns with it. And I did a lot of tuning to try to get it so that it's only picking up the reds, or sorry, the orange. On the image I also presented, I've got some reflective stripes, and that interferes with picking up the whole cone. So what I've done is I've created a kernel filter that's higher than it is wide when I'm looking for, a blur filter higher than it is wide when I'm looking for the cone, and that helps get around the reflective stripes.
And Pat, this is OpenMV, or what's the actual engine that's running all this?
This is OpenCV.
Oh, CV, sorry, yeah.
Yeah, so it's OpenCV on a Raspberry Pi 3B+.
So
Those are Python.
So, and then OpenCV, can I give it a trained up model and it knows how to can it use a TensorFlow model?
I can put TensorFlow on it and use it. But at this point, I'd have to use separate software to put the full TensorFlow package on to train it. There is a nice smaller package, TensorFlow Lite, that I was looking into, but then I would have to train it possibly on my laptop or something to get the model. And then just once I have the model files created, is moving them over. I decided to just go with OpenCV, and the hope is that there isn't a lot of orange on the day of the contest. Although my thinking is with the place I've picked that I am driving towards a highway at some point. So who knows with tail lights, car colors, what we'll see.
Maybe somebody call in an ambulance about the time you're ranking your run.
Oh, no. Maybe one of the competitors.
No swatting competitors. It's not allowed.
It's not in the rules. Just saying.
If you can find the right 911 number and have them actually find Macaro, Ontario, population 253 people or something.
You're giving too many hints.
Yeah.
on video.
That might be about the time when a whole bunch of Japanese tourists in Dayglow colors come jogging through.
That's right.
So I still haven't got an answer back. Usually there's nothing ever going on at that field, but I've sent an email off to the township to say, hey, I'm looking to do this competition that day. And is there anything going on that would prevent it? Am I all right to use it? I haven't received an answer.
They probably called the Canadian or military to make sure that you're not actually like do something really. You said robot to a town of 250. They're probably thinking killer robots.
So I was looking for traffic cones, and I said, "There's no way I'm buying traffic cones to do this. I got a better use of $50 or $60." And so I mentioned it to my brother-in-law. He's the one that gave me the little 6.5-inch cone I'm testing on. But yesterday morning, I get a text message. Look out your back window. I got 3 traffic cones sitting in my backyard. He went to see the township office here, and he said, "Hey, my brother-in-law is doing a robotics competition, and he needs some traffic cones to do a test for till the end of August." So I got 3 traffic cones delivered.
Yeah, Pat, you already asked for an exemption because of the reflective stripes, and that's fine. But if it's really getting you hard for you to do around them, there's a fluorescent orange tape that you can buy. Do you have Handy Depot there? I don't know.
No, Handy Depot? No.
I know, Home Depot.
There's Home Depot about 70 kilometers.
Oh, okay. Well, I'm just saying that you can also get it from Amazon through the mail. There's if you look into our rule page under the how to make a contest can, I believe it's referenced.
Okay. So
Yeah,
the other one I was wondering, Doug.
Just put it over that glow thing if it'll make it easier for you. That's all I'm saying.
Can I use an orange, fluorescent orange construction paper? Just an orange color to get rid of the stripe.
Yeah, go for it. Yeah, that would work too.
So that's what Ray's got up.
Yeah.
It's
Yeah,
cheap
just some way to get. I mean,
from Walmart.
The fluorescent stripes aren't. A lot of people would say, "Oh man, that's going to make it easier." In actuality, it breaks up the target, so it's not necessarily a good thing.
Yeah, that's the problem I have is I can't come right to the peak of the cone because I got these 2 reflective stripes in the way.
Okay, another thing too that might be when you're tuning your open CV model, and sometimes you can, instead of just having like one target, you could list yourself 3 different ranges.
I've done that.
Okay, so you have different targets, and if any one of them picks up, then you say, "Oh, this is suspicious. It might be a cone,"
Yeah.
Okay.
So I'm using 2 different targets right now because it seems to wrap around the 0 end at one point. I'm in the high.
Okay.
In the high 170s, I think,
Yeah.
and then it wraps back around to 0, 1, 2 sometimes.
Okay.
And I think part of that is reflection.
Yeah, could be. Like I'll tell you what, here in Texas, I have come out and looked at the cone, and the cone looks, even to your eyes, looks just like white because it's so the sun is blaring down on it so brightly that it just, any camera you have is totally saturated, except for maybe a little bit of shadow around on the lower left side or the right side, depending on where the sun is.
Okay, so
there's nothing you can do in that case, but
no, that's where my blur filter helps out a little bit, is just expand everything out, and hey, it's a big enough target I can see it.
Yeah, cool. I still want to. The answer about the TensorFlow. I don't know. Somebody asked if it could be put on a Pi, and yes, the answer. That's what Donkey Car is. Donkey Car is basically TensorFlow on a red, and they were using 3Bs. So it is Donkey Car project might be something you might want to look at if you want to pursue that particular aspect of it.
I was looking at one. I had seen an article and I can't find it. It was on I think a Cam Jam car, a little one you build in a cardboard box with the 2 yellow motors and a Raspberry Pi, and they used the camera with it. And I think they used TensorFlow, or I'm not sure what it was, but basically the car was on a tabletop. So they ran this on a tabletop, and they trained it with a go no go model basically, so it wouldn't go out drive off the edge. And they took about 60 pictures around on the table. Good, not good, good, not good. Filed them into a couple different folders and ran the model. And this thing worked surprisingly well.
Mhm.
And that's where I was going to say, take pictures of traffic cones and whatever else and try to train it. Is it a dog or a traffic cone?
Yeah, that's what I'm trying to use a little bit of the same approach. I don't know if I'll have it this year, but that's one of the things I want to do. It's either a cone or it's not a cone. And one of the things, though, if you want to see something, a donkey car example, we actually had, if you go back into the website and you go back in meetings, you'll find where Russ Milburn ran it. And we, unfortunately, his initial run, we didn't take. We didn't video it. We only videoed when he kicked up his speed up to like 150%. But even that is impressive. And we never really understood whether donkey car, it's got this course it's supposed to go around. I don't think it doesn't memorize it's not just trained on the course. It literally is trained on the room. You know what I mean?
Yeah.
Yeah. I mean, you don't
Whatever's
even
in the camera field of view.
Yeah, whatever's there is what it's trained on. So it's pretty. It is when you watch a robot doing like, I think he did 15 laps or 20 laps in 3-minute time period, all the way around the room, and you can look at the video. It's really, now the one we have is his second run, but you just have to take I think if you read the article, you'll see that he really did great. I mean, now he wasn't using a Raspberry Pi. He jacked it up to an NVIDIA board, but that's, in theory, you could do it with the Raspberry.
I just wanted to point out one small difference there when it comes to what you're talking about, dog versus cone. That kind of model is classification model. It doesn't actually give you where the cone is in the image. It'll just say whether there's a cone or no cone. In order to do where the cone is, you need to do something called object detection.
Object detect, or actually object tracking, I believe is the correct term. And yeah, that's but it's
more challenging. You need to take a picture, label the pictures, but saying this is the cone, this is the other things are not cones or whatever, and then you start training it. There are certain models like YOLO and RCMNs, etc., which could be used to do something like this, but they're more resource intensive, and also it takes a lot of time just generating those images and labeling, unless you can find a data set online.
Yeah, well, I'll tell you, one of my biggest problems, and one that I would love to get some instructions on, of learning the models, is how to take the training images. I've played around taking training images of different objects, and I've never been really happy with the results. Now, with the tracking model, basically you just take pictures of the cone close and far, close and far. Since it's symmetrical, it doesn't really matter. You can alternate around it, and then you take roughly the same type of pictures, but you don't have a cone. So you build up. The only difference is the cone has this high probability of having this shape, and the other ones don't. They're just random shapes, and that's how I'm hoping to get it up, because so many of these object identification type algorithms, they're really good at picking out a person, because people spent so much time trying to pick out people, but it causes, sometimes it calls my dog a cat, sometimes it calls it a bird, or I'm trying to get at it there. Once you try to do more than one, it seems like you really have trouble with it. But anyway, we'll see. Donkey Car was a real eye-opener for a lot of us in the club. I mean, that was pretty cool stuff.
Yeah, I didn't think I'd have enough time to get that in for this contest.
Yeah, I'm with you. There is a shortcut. I don't know how good it is yet, but I happen to have one, so I'm going to give it I'll be playing with it in the next week or two. There's a product put out by DF Robot called Huffy Lens. Yeah, Huffy Lens. And it does have that model built into it, and you can train it, just sit there and train it, and it's local training. And I don't know how good it is. I haven't really messed with it, but it would be, if it works, it would be something that would work. What's that? I see something.
I think that's a Husky lens.
Oh, is it a Husky lens? Yeah. Yeah. There were, like I say, this is a real case. I'm really interested if the Chinese just have a different sense of, like if we're trying to increase, we're going to push things to the left. If we want to decrease, we want to push things to the right. Well, there's this, if you want to increase it, you push it to the right, and you decrease it by pushing. Everything seems a little bit weird for me, and I'm having a little trouble. It's only got 2 freaking buttons, guys, and I'm having trouble with it. So, I mean, I don't know what's going on, but it's, I'm sure once I can get it to work once, I'll be happy with it. But I do have one little, well, since I'm talking, one little quick update. It won't take a second. I've now added ultrasonic to this. Now, what this is a stand-in model for my outdoor robot. And all the things, so, oh boy, he's got ultrasonic, big deal. The thing that's the big deal on this is they're all using the change pin interrupt, and they're all running at maximum refresh rate independently in asynchronously. So, and I'm going to have those little sensors that you saw up here at the top. I'm just right now in the process. I've just printed out their package. There's going to be 45, which would be the wall following one, and a 90. Might not need that one, but I'm going to put it since I'm doing it and I have them. So anyway, so I have figured out a way to make non-blocking ultrasonic measurements, and I feel good about it. So that was one of my, which by the way, again, it had more than 2 buttons, and it took me a lot longer than the other one is going to. I mean, it's amazing how many typo mistakes and copy and paste mistakes you can make in a code. So anyway, we're getting there.
I went the other route with that, Doug.
Yeah.
I used some blocking code. I used the new ping routine. And so I'm pinging 5 of them in a row sequence. So I've given 30 milliseconds between pings. And then it gives me time to update some other stuff and send everything out. I seem to be having pretty good luck with it.
Oh yeah, I mean, it'll take readings. I have noticed when I've been trying to do, if your primary sensor is ultrasonic, and a lot of things can happen in 30 milliseconds if you're traveling a good rate of speed. And so I'm not saying, but you're right, they can do it. What I would have done probably, Pat, on that is run that on a separate processor and just push the 5 numbers over to my main processor. You know what I'm saying?
Yeah, that's what I'm doing is I'm only using it for ultrasonics. I've got a little Arduino Nano.
Yeah.
It's using the 5 ultrasonics. And then I also power 2 servos for a pan tilt on the camera. And
not on the Nano.
On a Nano.
You got 2 servos and 5 ultrasonics?
I've got two little micro servos.
Yeah, what I'm saying is that you probably need independent power for that.
It is powered. Yeah, right now I'm having no issue with it.
I'm amazed. I'm absolutely amazed. Now,
The servos are only driving a little pan zoom tilt mount on it for a camera. There's hardly any
Yeah.
load on it whatsoever. The biggest problem I'm having with it is jitter on the servos, just because they're crappy little cheap servos.
well, here's what I found on that. I found that if you're using a 9-gram servo, you can get away with 1. That's the way I've always found it. When I put more than 1, then you get into iffy, and you could be getting brownouts and just resetting. If you got a real small loop, you might not notice right at first that you're resetting all the time, every time the ping pops. But if you got 2 servos going, and now you're only, since you're using blocking code, the 5 ones aren't all firing at the same time. They're going boom, 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 boom.
Yep.
So you're only using one ping at a time, or one ultrasonic sensor at a time. So you have 1 ultrasonic and 2 servos. I still think that I would recommend bringing over a non-Arduino board power to handle the servos, at least. And I'd actually put the servos and the ping on that. I wouldn't load down the bus on my.
Are you using SG92, those SG92R micro servos, the really cheap ones?
They're super cheap ones. They're down to a couple bucks each or whatever they are.
Yeah, SG92R, I think is what they are.
I think they're SG90s.
Oh, SG90, yeah. Variant of the same thing, yeah.
You're not using the M?
Nope.
Okay.
So I'm not using them. I know they jitter because I can see them in my video. You can see them move over once in a while, a little wee bit. But I also do a pan routine where I pan the camera back and forth, looking for the cone, and I'm not having any issues with resetting at that point. I am only, though, running 1 servo at a time. I'm not running the tilt on it.
Okay, so you're only running 1 servo at a time, too.
Yeah, so I'll be doing either the pan or the tilt, but not both at the same time.
Like I said, I've been able to run 1 without too much trouble. I actually have some on ultrasonic. Sometimes I can run 1, or sometimes I have to go to external power. You can put a little capacitor between VCC and ground to help that. Keep your ultrasonic from dropping the voltage on the line.
I think I was having a problem with my Raspberry Pi in voltage drop last week. My voltage regulator, it's a drop down regulator, a buck regulator, and I needed 6.5 volts on the input minimum.
Okay.
So 6.5 to 5 volts. I'm running, I think, 5.21 volts coming out of it. And every once in a while, my Raspberry Pi would reset. So scrambling, trying to get ready for the contest, I ordered a couple more batteries. So I ordered some 11.1 volt instead of the 7.4 volt.
Yeah.
And so I've got them in, and everything so far seems to be better.
Yeah.
How much are you driving? How much are you sourcing off of the Raspberry Pi GPIO?
Off the GPIO right now, all I've got is an IMU that doesn't have a magnetometer on it, and a little OLED display.
Okay, cool. I mean,
but I am powering some USB.
The USB is not concerning. That GPIO can only drive like 50 or so milliamps, maybe just a little over that.
Yeah, there's nothing in there
It'll reset itself if it goes over that. I'm only saying that could be an issue there too, but you're not driving anything off of that. That's why I asked.
No.
So that's not an issue.
So the only thing that's coming off there is the servo motors, which may be a little bit of an issue. Might be 100 milliamps to move that little servo with no load on it. The motors on the robot itself are driven from separate from the battery. They're actually driven directly off the battery right now.
If anybody has an issue with or that kind of problem where you're current limited. Kind of as a side note, at Micro Center they have an inland brand Uno, and instead of the linear regulator, it's got a switch mode regulator on it. It's got a USB-C connector, and it's got switchable 3-volt, 5-volt header pin for all the analog inputs and most of the digital inputs. So it's a definite improvement. It's $9. But, and if you know, like I said, if you had an issue with that little linear regulator that's on there, the 1117 or whatever it is.
I think it's a 1505, and then, but anyway, whatever it is, I know what you mean.
Yep.
Yeah. Yeah. Steve turned me on to one of those switching regulators that I needed for another project, and they were definitely way better. Way.
Oh yeah. Yep. Anyway, that's built into the Uno board, the inland board.
Yeah. So I have to look at that. That. You say it also has the pinouts done in ground, signal, and power?
Yeah.
Good.
I think I want to say for all the analog and most of the digital.
Mm-hmm.
Oh, did I lose you guys?
I'm still seeing you.
Okay, good. Everything froze for a minute there. Second.
We haven't heard from Harold.
No, you have not. I can show some things. Give me a second here. You might want to pin me because I'm going to switch my camera to my desktop. And so you can see. You may see some things you recognize on there. I've been taking pictures. So I've been having some bumps in the road with my XOMI to get it to go in the autonomous mode doing things. So one of the things I know I needed to do was, much like the rest of you, have been training up models to recognize a cone. And so I found a cone. I went and took a bunch of pictures, different angles. You guys can see this right now if you pin me up, right?
Yeah.
Other things in the way. Some of the stuff is, I mean, that's out in the grass and that kind of thing, right? And I took some stuff inside. One of my Twitch followers said, what if we reduce the size and change some of them to grayscale? So he spent today grayscaling a bunch of those same images and also reducing. These up here have been reduced to 320 by 320, and these down here were the full resolution images that I had. I stuck all that stuff in there, and what you do, like if I wanted to, this is actually pretty cool. I've already tagged these images, so it doesn't look pretty good. This is a custom vision lab, which part of this is free. When I mean free, you get an hour of training time a month and up to 5,000 images, and then you have so many online transactions to go do some things. So when I found this, as you see, as I'm moving around a little bit, you'll see where the computer thinks there's an object there, so it's trying to help me. Just so happens it helped me with that one. And when you click on it and say I want that thing, you get to give it a tag, and I tagged it with a thing called traffic cone. These are tags I made up. I can add more to them. For instance, if I turn that off, it's like, okay, where's my objects? If you look, you see where it draws the dotted line? It says, ooh, I think that's an object. And of course, I've only got one thing, and it helps me with it. And I get to go through all the stuff and do all the things, and I've done all that. Once you get done with doing that, you hit this train button here. And I've only done quick training. I haven't done advanced training, so I don't know how good this can be because I'm trying to figure out a few things. I'm to the point now where I have a model, and I'm trying to get that model running on my Raspberry Pi so that I can send some stuff to it. And how this works is after you train all these things up, I got a couple that are untagged. Like, for instance, I didn't tag that one apparently. And I have some images where they're not there. This is an object recognizer, not an image classifier. so I can only have positive images. I can't give them negative things. I can do other things, like for instance, if I wanted to do this, let's say right here, I can go here and go that right there. I can call that a fire hydrant. Okay, so now that thing knows 2 images there. And if I keep going through all these, I can do more fire hydrant stuff if I want. And this is how I'm showing the computer what a fire hydrant looks like. And I'll continue to go through those if I want, but I'll just show an example, because I'm going to show you an example of something else I'm training. Then once you train it, it spins around, and you'll see I've got a couple of iterations here. One's published, one's not. This iteration 2 took it about 10 minutes runtime of training up in the cloud. When I get done with that, I get to export this thing, and these are the things it knows how to export. And what I've been playing on right now is this Docker file in this Azure ML. It's supposed to give me a Docker file where I can run it, where it exposes a HTTP endpoint, and I can just hit it with an image, and it turns me back a bit of JSON with some stuff. I have yet to get that to work on a Pi. Kind of pissing me off a little bit, to be honest. Oh, we don't have little ones around at the moment, do we? I'm sorry. Age appropriate. And then I can download TensorFlow, and then Onyx, which is kind of a universal thing that can get translated. YOLO can get translated into it. A few other ones can get translated. And there's other things that have translated Onyx into other models. That's why I was asking about TensorFlow, because if I can get TensorFlow working, I go download this, I'll have a TensorFlow model that I can plug into it. And I've already got those downloaded in there. So I'm wondering how good this thing can be right now. And they give you a way to do it. So this is a test. And I spent one of my nights, Twitch nights, after I did this, sitting there doing nothing but throwing images at the thing and seeing what it finds. So in this case, you got a cone. It's not a full orange cone. It's got a stripe on it, a few other things. I grab the image link. I go back over here to my tester. I'm going to move this around just a little bit. Paste that in. Tell it to go, and it'll go out and find it, analyze it, and come back. And it has a little slider down here. By the way, we'll play with that in the future. But the slider is a threshold. So basically, if I roll over the top of this, it's pretty sure that's a cone. It's really sure that that's a cone. But the object is actually found in there is one of these, and it's pretty sure that's not a cone. It's identifying these as it goes. I found a few more things that I was playing with. For instance, let's say, everybody's tracking off a color, right? So let's look at this one. And give me a link here, and let's go off black. So we were playing with it, trying to figure out, what was it tracking on? And so I'm like, okay, let's let it whirl around, and it's pretty sure that's a cone too.
Damn, that's good.
It's pretty sure.
Hey, Harold, could you put the links to how to get started using that?
Absolutely. It's going to require an Azure account, but everything that I'm doing right now is free. You get an hour's worth of time a month of training, and 5,000. You can look at the pricing and see what's free. I don't want to charge anybody there anything. Azure. Let me make sure I got the right link. Yep. I've got to do it on a slightly different window.
How many images did you use to train your model?
I have currently 70 images. I downloaded 48 initially, and then 48 initially, and then one of my YouTube followers, Twitch followers, I gave him another 20 or so images, and he's the one that scaled them down to 320 by 320, and did the black and white on them as well.
Thanks.
Basically, what you have, let me grab that. There's like anything else, you got to give it a bunch of images, and there's two different ways you can do it. And what I'm doing now is what's effectively called object recognizer versus an image classifier, and this thing will do both. An image classifier, you can provide negative images as well.
Will it give you a position for the object, like an XY coordinate?
It'll give you a bounding box based on the image that you gave it.
So you can figure out like the center of it. Probably gives you like
Yeah,
width and then
all that kind of. I don't have a good example right now to show you the JSON that comes back, but it will give you a bit of JSON that includes the bounding box and the confidence interval and pretty much everything that you see on this screen here. That's what it's doing. It's giving me the points of this top, left, bottom, right kind of thing, and it's so I can draw it. So the program that's already in the web is drawing that on there for me, and also it gives me the confidence interval so that I can do a bunch of things here. And this is not all that good of an example, but for instance, it's not doing. It doesn't do great yet, because if I copy the image link of Mars, right?
I think Mars is a cone, huh?
Well, yeah, it's pretty damn sure Mars is a traffic cone. You know, so there's some color involved here. There's no doubt about that.
Yeah.
It's certainly not perfect. And there's some other things that are crazy. Why I just marked those traffic cones was we were playing around like, what about this? Let's pick one. I don't know. How about that one?
No, it's fire hydrant.
Fire hydrant. Now, remember, I got up and tagged it, but I have not trained it on fire hydrants yet. So, so it doesn't really know, but it's pretty sure that's a traffic cone too, because it only knows how to find. If it finds an object, if it matches its traffic cone-esque sort of things, it's going to call it a traffic cone. I teach it what a fire hydrant looks like, and it can probably do some different ones on it. I found some other weirdnesses. Well, actually coolnesses. For instance, if we go down here and let's do this. Let's look at that one. That's not orange, right? And it's pretty damn sure it's a cone. So it's more than just the color. It's more than just the shape. It's doing a bunch of stuff. That's a 99.9% confidence interval. In the world of AI and doing confidence stuff, it don't get any better than that. I found out. Go ahead.
Working on the conical shape or something, you know, like it's.
Yeah, we were playing, and well, there's some other weirdness like this one right here. I thought it would have found all of those. I got a similar image on here, and I went, let's go check that out. I had a fun for a couple of hours on Friday night playing with this. And in this case, I'm going to throw the threshold way down. See, all those red boxes are all possible objects. And if I go, anything under 50%, we can say it's probably not a cone. So right now, it doesn't think there's any cones there. Obviously, there are cones there. There's one there at 29, that's a traffic cone, and one there at 40. See, that just barely missed the cutoff. But if you look at what the box is surrounding, it's surrounding two of those cones and thinking that's a cone. So there's obviously some more training that gets to be done on the thing. And other weirdness.
Harold, I think you'll get by. We only have one isolated cone, probably no fire hydrants.
I think it's well. Here's
I'll be dressed as a fire hydrant.
You'll be dressed as a fire hydrant. Okay.
Well, here's the problem. Here's the problem I have is I did one of these things. I went and exported. I don't need to export this one, but exported this. I did it as a Docker file, thinking I just run this thing as a Docker file. Hit that with an image every so often. I don't know, however many times a second. My robot's not very fast. The times to do this thing on a cloud-based kind of thing, or at least we're talking here. They said most images are in the sub 30 millisecond for recognizing and returning you stuff. But I got a Raspberry Pi. I don't know if I can utilize the GPU on the Pi to help with that. Possibly, I don't know. I just want to get it running first, and then I do have some compute sticks around here that I'm just mad at those at the moment. But okay, let's run the Docker, and when I'm running it, I don't have my window up on it because my robot's right here. But I run it, and the Docker file doesn't build straight off the export. I don't know why. I'm beginning to suspect 32-bit versus 64-bit, and the Pi, as it's designed by Max and Miro with all the things on here, it's a 32-bit Raspbian, not a 64-bit Raspbian, and that may be causing me all kinds of problems. I figure, well, let's install Docker on my laptop here. Well, this laptop, for some reason, will not allow me to do WSL2 with Docker desktop on it, so I can actually even try it. So I'm blocked there too. I guess I got to fire up my work machine and see if I can make that happen. Because if I can get a Docker image made any way, shape, or form, and I can get it on the Pi, it may work, and I may just have a URL endpoint that I can fire local from one Docker image to another to get that and give me back a bounding box and that kind of stuff, and then I can do something with those things. And I was thinking to do something very, very similar, like I believe who was doing it. It wasn't Karim, or somebody else. I forgot who was doing it on my grid, my Brady Bunch grid of people. But that
wasn't it Murray.
It wasn't Murray. Wasn't Murray. But it was like I got an image. I got bounding boxes. I know on my image about where it is. I know what size the cone is. I can guess now the distance because of the size.
That was Pat.
That was Pat.
And then I should be able, since I've got that, maybe that'll give me an angle to adjust my angle towards it. I'm thinking I could do something along those lines. But until I get that recognizer working on something local, because I'm not sending all at one, I can't. The rules forbid a connection to the cloud. And so I'm like, okay, that's fine. But so I need to work it on here. Until I get that working on here, I'm kind of toast at the moment about making the robot actually, because it's not going to drive straight. I know, Carl, you say if you drive straight, no. And I'm a big fan of doing it, but I can almost guarantee you outside, if it was smooth concrete and that kind of stuff, I could probably tune it to drive straight. But as soon as you throw grass and even the putting green grass, even that's going to thing, depending how far it is, you're probably not going to drive straight either.
You just need a control loop.
I suppose, yeah. I got continuous servos. I've got no feedback.
No feedback. That's the issue right there.
Yeah, I got zero feedback. If I had zero feedback, maybe we could do some. If I had any feedback, we could do something. So
feedback is for
runway on making this contest, but I'm still going to try until I can't. On this thing, and it'll still show up, and I'll still turn it on, let it run. What the hell? Maybe I'll get a point. Maybe I'll have a chance to get close enough to get a point. Maybe. Who knows?
You get some applause because what you got's already pretty cool, Harold. So it's a good deal.
Thank you very much.
Absolutely.
And so that's an offering from the Azure world of doing things. And you see when you get done training, it tells you a few things. Precision is how accurate it was on playing back the images to itself, that it could tell it saw a cone when I said it was supposed to see a cone. The recall is the number of tags it predicted correctly. So 78.9% of those images, it actually predicted correctly as what it expected to predict correctly. So maybe I need to work on my image and definitions and things. And this this map down here is the mean average precision. Number will tell you the overall object detector performance. So it's if it detects out, it's got an overall of almost 89%. That's really good. From what I know about AI, that's really good.
I applaud you building your own, going through all that trouble. Have you tried it against any comparing against any pre-built ones?
On no, I haven't. No, I haven't. There are pre-built there are pre-built ones out of Azure. I've not grabbed any of those models yet. That was going to be my next plan. That if I could get to the challenge cone and I needed to do object avoidance, I was going to see if I could grab one of those pre-built ones and just say, if there's a block that shows up anyway, turn. Something dead stupid simple like that. Yeah, but I'm going to be really far away from that at the moment, I think. So that's not a concern about it. But there are pre-built ones for all kinds of objects.
Well, I posted a pre-built one in the chat for traffic cones. Doug, did I hear correctly? Your robot's not allowed to connect to the cloud? Because the RTK robot requires a correction signal.
Well, it also allows RTK, so the rules are a little.
You should be fine. You should be fine.
Yeah, I think what the purpose is, I think the intent of what I was reading that is that all the compute, all the decisions, all of that kind of stuff has to happen on the robot itself. It can't be just a remote controlled extension of some smart thing up in the cloud or off to another. You got a laptop running somewhere else. That was what I understood the intent of that rule to be.
Right. The intent was just things to be as independent as possible.
Yeah.
And but RTK is definitely allowed this year.
Explicitly allowed. So
explicitly, yeah. So now, I think what we were thinking was that you would have your own correction station someplace near the course.
Right.
But I don't know if you don't have that equipment, just do it over the cloud. But you got to make sure you can. Doesn't the distance from the correction, shouldn't it be close to where you are? Remember, we're going to be in. Is it Greenville? No, it's not Greenville.
Yeah, actually,
Farmersville.
I found an RTK to go reference station up there.
Okay.
It should be right around. It should be close enough.
Okay. Well, yeah. I mean, I would love this. This is all about us learning and getting better. So we'd love to see an RTK version out there.
Oh yeah.
And I mean, just that's. But like Harold mentioned, the overall thing is, if you were going out to the cloud and getting some sort of all your robot did was set messages from the cloud, that would be probably a stretch, because we would really like the robots to be independent.
Sure.
So what is it? It's like 10 kilometers, 6.2 miles away is the max, or?
It's not a hard max. It's in fact, there's people doing long baseline versions of it, and it just gets to be a muddier and muddier correction. But this station, I think it's in, what was that, Princeton? There was another town up there. It's actually over in Princeton, and it's about 10 kilometers away. So it's kind of right on the edge of decent signal.
Actually, I didn't know there was much up there anyway. You know what I mean?
It just showed up in the last month or so. I mean, because up until recently, there's only been 2 locations around the Dallas area, and now there's a new one.
Okay, well that's cool. Yeah,
Probably a guy that should be a member of the DPRG then, right?
Yeah, honorary.
Yeah, there you go.
So anyway, yeah, go for it, Kareem.
I'll see if we can pull it off. Yeah.
Yeah.
Right now we're working on the Timaroni, the
Optical.
optical flow sensor. Yeah. We just got that working last night, just in a test case on a Pi. The bigger challenge for us is to convert it over to the platform we're using. And I'm sorry, I think I interrupted Harold.
No. It's all right. I was about done showing all I was going to show. I was going to continue to whine on for another 35, 40 minutes.
You would expect no less from you, Harold.
Hey, Kareem, I would be interested in hearing if you've got any sort of interim results on that sensor.
Oh, it's not deep testing. It's still just on a bench. So it was just getting the data back and sort of emulating a mouse with it to just prove that because we were having problems. We had the configuration a little bit wrong, but it's giving good, consistent results. And we just got a ways to go before we can get it on our standard platform.
Cool.
Because as far as I know, there's only the Python library, and
Yep.
we're using Java, and we don't have SPI, so we're going to have to go through an I2C to SPI bridge.
Why don't you use Python?
It's not allowed on our platform.
Oh.
Right? We're trying to stick to whatever is allowed for the competition.
Gotcha.
Because they hope to provide it to other teams for next year's competition.
All right.
Oh, Doug, I had another question real quick. I posted up a little bit above in the chat a link to a whiteboard, a jam file at 9:03 p.m. And I was wondering if that was you in that picture, because you can't just paste pictures into the chat here. Is that you in that seminar from 2014? Doug?
Who, me?
Yeah.
Oh,
Which
that's
seminar?
Doug.
Which seminar? I'm sorry. I was setting up a 3D printer there.
Oh, sorry.
Yeah.
Scroll up, scroll up to 9:03 in the chat.
Okay. Chat.
Is that you? Because I thought I saw you in that. I that was like an all-day seminar. That was like session number 5 of on field-oriented control for BLDC motors, or actually any kind of
Oh,
motors.
yes. I was an attendee. That makes me look like I'm making a presentation. It's
No,
actually
you're just walking across the.
Yeah, that's probably me going back to my desk and sitting down.
Yeah.
Yes.
He was heading to the men's room.
Yeah. Well, they're probably the snacks where you see that. You can see I've got a slight overhang there. So, yeah, that's me.
That was far out watching that and seeing you in there.
Oh,
that was like 6 hours worth of workshop, something like that.
Yeah. Did you? So that's online now. That was actually very good, but
It was incredibly good. I mean, there's long sections of really deep dive stuff, but I sort of wish, and it goes all over the place from PID to really low level field sensing and different. Yeah. And it was just I wish I'd seen that back when it was, when that was posted, because it would have cleared up a lot of mysteries for me. Because I'm just getting into BLDC motors, and so I just wanted to understand it a little bit better, and just ran across that.
But can you put that link to that?
Yeah, sure.
Is it a whole day of the whole day is there?
It's broken up into like 5 different videos.
Yeah.
They call it Teaching Old Motors New Tricks.
Yeah.
So it's the part 1 through 5, and you're gonna it'll lead you from part one. I just posted part one,
Okay,
and
cool.
it'll lead you through all of them.
Yeah, because that is definitely a good one.
So is that put on by TI?
It was TI, yeah.
Yes. And it was one that was actually cost money. You know what I mean? It was not one of these
Yeah.
freebie ones where you go to. It was, and the guy they had, there was 2 English professors, I believe, if I recall right.
The
And
guy
they-
that's in this section is American,
Yeah.
but there are other people like other sessions involved. Clearly, this was just the one session, but it ended up being a full day long.
Yep.
But really, really good content.
Yeah. Well, I'm gonna.
All right, that's cool. All right, so we've gone around the table and our numbers are dwindling. Has everyone had a chance to go that's wanted to go? Has something to say? All right. Sorry I had to bug out there for a few minutes. It's just a call I had to take, but thanks for pressing on.
See you around, guys.
Yep. Have a
Yeah.
good week.
So you guys have a
Bye.
great evening, and we'll catch you next week. Raj, I'll see you Thursday night.
Yeah, see you Thursday.
Take care, guys. Bye.
Take care, folks.
Bye, guys.